we're gonna go ahead and get started. So if you can find your way to your seats, that would be swell. That was very speedy. Good morning. We're so excited to welcome you to the first workshop on generative AI in law. And Cooper and I are going to be giving the opening together. So I'm Katherine. It's nice to meet all of you. And thank you all for the wonderful discussions that we've already been having at this conference. So this is a pretty, unique time in technology, and it's been fun to see the rise of generative AI and also think about some of the legal questions that raises and some of the questions that maybe law has for generative AI. So we're excited today to bring together a wonderful set of two different communities, both technical scholars and legal scholars, and learn a little bit from each other. So to get started, we have some goals so that you know what our goals are for today. Because we're coming from many different disciplines, not just law and computer science, we want to arrive at some common language. And we want to be a little bit precise about what the words we use are. That way, when we leave here today, we can say, yes, we agreed, and we also know what a model is. Just to give you a sense, models are a word that is very overloaded. It can mean anything from the API that you use to the model weights. So hopefully today we can start to tease apart what those differences in definitions are, and then hopefully come together to some shared understanding. Another thing for today, since this is such an interesting interdisciplinary work, hopefully we'll have some shared research directions that come out of this. Hopefully we can get a little bit of clarity on what the questions are. Great. So today, even though there's a lot of other questions that generative AI raises, these are the two that we're going to focus on. It's going to be IP and privacy. The IP section's a little bit longer, but that's because it includes lunch. So in between those two, we'll have these spotlights and posters, and we see some of our poster presenters already putting up their posters. So if you have a poster today, you can come and grab some stickers and then put them up around the room. That'll be after lunch. Great. So this is the more detailed schedule. You can also use our QR code and go to our website. The website is really easy to find, genlaw.github.io, in case you want to reach it a different way. And in the morning, we're going to start with Pam on a talk on copyright. We have some really incredible speakers lined up for you today. So really excited to hear from these folks. Okay, so what exactly are we talking about? All that talk about precision, what exactly do we mean? There's many ways to break down this problem. This is how we're going to break it down, and some of the speakers may break it down in other ways as well. So when we talk about generative AI, there's many pieces, including dataset creation, model training, and model serving. And dataset creation is really complicated. There's a lot of choices that you make. And just to give you a sense of some of those choices, that can be from what type of data, image, text, audio, music, etc., and how much of that data. As our models get bigger, we're able to ingest more data. Also questions like, are we going to use web data? What web data? What makes data good? Or data bad? Or useful? All of these words are not defined, by the way. So they're our choice on how we define them. Okay, and then the question in the room, how about copyrighted data? Can we use that? What about private data? What makes data private? And can we use that? So there's a lot of choices here, and we delve into this a little more in explainers that's on our website. This is a very long document talking about some of the history and some of the incentives for ways that data sets are created. Okay, and all of that data is then fed into the model. And the way that we design our model also impacts the type of data that it makes sense to include. So some examples are, if you use differential privacy, maybe your data set would look a little bit different. If you use a retrieval-based model, maybe your data set or data sets would look a little bit different as well. So there's a lot of choices that go into model training that also impact the choices for data set curation.
And lastly, we're going to talk a bit about model serving as well. And we're going to use this term loosely to bucket several key parts of generative AI that have to do with interacting with the model. So prompting, generation, fine-tuning, feedback. Prompting, for example, can happen as a part of evaluating the quality of a trained model during pre-release, but it can also happen after a model is deployed and running in an application. So users use models like ChatGPT using an online interface produced by OpenAI, and let's basically say that they're going to prompt the model, but then also we can also use them prompt them during testing. So we're going to talk a bit about prompting generation in a bit more detail. So tackling these two together, we have our trained model, which is trained using the input training data. And as Katherine said, the model gets updated as it processes the training data during training. But there's another way that we can provide inputs to models other than training data. A user can provide a prompt to the model, which then results in the model producing an output or a generation. So in this case, the prompt is 2 little robots sitting on the beach reading law books, and the model generates a little picture in response. Fine-tuning is very similar to the training process Katherine already talked about. In that process, training data is supplied as input, and we use it to train the model. And we can consider the resulting model as the base, or sometimes called foundation model. So an example of this would be the model weights for GPT-4. That would be a base model. And from that, we can then think of fine-tuning as doing some more training on the base model to make the model more useful for a particular domain. So again, for example, if I want to fine-tune GPT-4 to answer questions about scientific knowledge, we can fine-tune it by training it a bit more on scientific text data. And then we can take the fine-tuned model and let users prompt it to produce generations. And once we have produced a generation, we can then ask the user for feedback on whether the generation was good or bad for the output prompt, a good or bad output for the prompt that was supplied. We can then use that feedback information to further update the model to align with what the task is supposed to be used for. And each of these actions, prompting, generation, fine-tuning, human feedback, can be done or implemented in a variety of ways. So, perhaps unsurprisingly, model serving also involves a lot of choices. And hopefully by now, you're sensing a recurring theme, which is that there are a ton of choices that we make all the time when it comes to generative AI, when creating data sets, when training models, and when serving the model. And the great thing about all these choices is that they implicate concrete research questions, at least in the technical space. And we have the really cool job as machine learning researchers to precisely define and study research problems located in each of these set of choices. But as we are finding out right now, these choices also actually implicate a lot more beyond the purely technical space. So for anyone who's been following the news, there's been a ton of public interest in generative AI, not just the capabilities that it affords, but the potential legal issues that it presents. So in particular, it seems like almost daily, there's a new intellectual property related lawsuit posted against a company that produces base models. And one of the important points about this, for those of us here today, is that as ML researchers and practitioners, the research we're doing in generative AI models is getting incorporated into products that are served to the public. And these products are very quickly having broader ramifications out there in the world, especially for things like copyright. There were more lawsuits, great. And these legal questions are also currently, for the most part, unresolved. And a big part of today is bringing together experts that work on both sets of these questions to knowledge share and see how current research in generative AI can help inform the legal community about the scholarship they're doing, and how concrete legal issues can hopefully help shape the kinds of choices machine learning researchers make and the research questions that they choose to study. And so, as Katherine already mentioned, for this iteration of the workshop, we've chosen to center on themes of intellectual property, which is mostly going to involve copyright, but we want to also make clear that copyright are not the only IP issues involved in generative AI, and then also privacy. And we'll defer to the experts to get into details of what we mean by IP and privacy. So with that, we're almost ready to kick off the day, and I'm about to pass things off to James Goleman, who will introduce our first speaker. But before doing that, I want to acknowledge all of the GenLaw organizing team for the work that they've done to put on today's workshop, which is hopefully the first of many. And in case any of you have any questions throughout the day, we're all going to be wearing these light blue hats so you can find us easily. And we would also like to thank all of our sponsors and partners whose generous support has made this workshop possible. And so with that, here's the schedule one more time. And again, as Katherine said, it's on our website. and I'm going to pass things off to James to introduce Pam Samuelson.
Good morning. It is a great pleasure to be with all of you here today, and it is a great honor to introduce our first speaker, Pamela Samuelson. She is the Richard M. Sherman Distinguished Professor of Law at the University of California at Berkeley. Much of her scholarship is focused on how intellectual property law should adapt when advances in technology raise liability questions that Congress did not anticipate. Her most recent article is Generative AI Meets Copyright, which was published on July 14th, 2023, so 2 weeks ago. She's been a contributing editor to Communications of the ACM since 1990. And let me now see if I can get her slides up. Oh dear.
Oh, the technology.
Yes, I'm having Wi-Fi issues. Hello. Challenges. Yeah. Wow, yes. Okay, let's use this computer instead. I know, but the slides are in my email. This is what we need to use. Thank you. Are we good? Yes.
So thanks. Thanks for the invitation. This has really been a fun thing to plan for. So I'm very glad to be here, and I look forward to your questions. So I want to address three principal questions. Actually, I'm going to defer one of them to my friend and colleague, Mark Lemley. When, if at all, does making copies of copyrighted works as training data infringe copyright in those works? I call that the big kahuna topic in honor of Hawaii. When, if at all, are AI-generated outputs infringing derivative works of the ingested content? Most of my talk is going to focus on that. And then when, if at all, is removal or alteration of copyright management information associated with copies of works violate a copyright-related rule? And I'm going to address that one first. This one is a really big ticket item, okay? Because each violation of this copyright management information comes with a minimum of $2,500 statutory damages going up to $25,000, okay? So most of the generative AI lawsuits that are raising copyright issues also raise what I'm gonna call 1202 issues. And so I think we can't just focus on regular copyright. We have to think about 1202 too. So what is that law anyway? It makes it illegal to intentionally remove copyright management information, such as the name of the work, the name of the author, and terms and conditions under which the work is available, knowing that the removal or alteration of that, that data will facilitate infringement of copyright. And the law was enacted in 1998 because there was concern that without something like this, that what would happen is a copyright owner would put the work out in digital copies with copyright management information attached to it, and bad guys would basically take that copyright management information off and put their own name in, and then start distributing it in competition, and that would actually undermine the ability of the copyright owner to be able to control. The other worry was that hackers, the bad guys, would be out there and they'd strip out the copyright management information and then distribute the work as though it was in the public domain and available for anything. So that's what the law was really intended to address. But of course, it becomes a very important part of the litigations in these cases. And so, as I said, the complaint in the GitHub case estimates the statutory damages in that class action lawsuit of $9 billion. And some of the others only allege $3 billion, but the point is that we're talking in the B, not in the M range, and that's important. And so the question of whether this particular law is violated in the course of training models or in the course of producing outputs is something which the courts are going to have to address. And the initial motion to dismiss this claim in the GitHub case was rejected by the judge, so it's a live issue. To give you a kind of a bit of a sense of this, if you look at the image on the left, you can see the Getty Images logo in it, and then the one on the right is a kind of mangled version, right? So that's an example of a kind of alteration of copyright management information that Getty Images is claiming is the basis for its 1202 claim. And I'll come back to that photograph a little later to talk about whether these two images are substantially similar. I thought before I got into the heart of the talk that I would basically be a little more precise about who's getting sued and for what, and by whom. So Stability is the defendant in two of these cases. Getty Images is one of the plaintiffs. There's a class action lawsuit in which Sarah Anderson is the named plaintiff, and it raises the training data and output issue that we'll principally be talking about in this first part of our discussion of generative AI law. OpenAI is also being sued twice by the same lawyer. Actually, the two complaints, the Silverman and Tremblay class action lawsuits, are both on behalf of all authors whose works were used as training data to make the model that underlies ChatGPT. Meta has been sued also by the same lawyer, another class action lawsuit for copyright and 1202 violations, and then there's another lawyer who brought a couple of lawsuits, and so Alphabet, Google, and DeepMind are also defendants in that case. These are the non-copyright lawsuits that are out there. Most of them are also class action lawsuits. And privacy violations. The most probably significant of them is the OpenAI, GitHub, and Microsoft case that was filed on behalf of 4 John Does, and it focuses on Copilot and its use of the OpenAI Codex LLM to generate code in response to prompts by users, and that has a breach of open source license and 1202 claims, but no copyright infringement claim, notwithstanding the fact that it talks about piracy, 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 but there isn't a copyright claim in it. There's also a lot going on in Washington, D.C. right now. So Congress has held several hearings so far, and probably will hear more. The Copyright Office held some listening sessions allowing stakeholders who wanted to express their interest to come and make points to the Copyright Office. The office is going to issue a notice of inquiry probably sometime this summer or early this fall. And what that means is that they're going to ask a bunch of questions, and they want answers to those questions. And people in the generative AI community really ought to take this seriously, right? Don't just let Hollywood and the Authors Guild and some of the other strong rights holder groups basically dominate this thing. You have to get your word in about why copyright should be interpreted in a particular way. Now, why are these lawsuits being filed? Well, the class action lawyers who are bringing them see the potential for awards in the billions of dollars, and usually the they take it on a contingency basis, which means that they don't get anything if they lose, but they get about a third of the take if they win. And that's a pretty big financial incentive for them. Of course, some of the members of the class will get some money too, but not probably as much as the lawyers. So the lawyers cash in on those kinds of cases. And of course, it's also a chance to make new precedents, burnish your reputation, and attract new clients. But it's also the case that they can't make these things up without clients who actually are upset. So it's really important to understand that there are a lot of people out there who are really, really angry about the use of even stuff that was posted on the internet as training data. And I think this particular image kind of gives you the sense of what the objections are. So copyright in a nutshell, I'm not going to try to do much on this because I think you can read it pretty fast, and some part of copyright law actually makes sense. What we're talking about here mostly are reproductions and derivative works as exclusive rights that may be violated by these generative AI systems. But I want to focus a lot on original expression, because copyright law doesn't protect everything in a work. It basically only protects what we call original expression. What is expression? Well, some part of it's obvious, right? The melody of a musical work, sequences of words in poems, lines of source code, and the like. That's obvious, but there's also a kind of recognition that something can be substantially similar, so it's not identical, and not even close identical, but it could be still substantially similar in expressive elements, so that there is infringement found because the defendant improperly appropriated expression from the plaintiff's work. And one of the things that we're trying to sort of measure as the courts and juries try to make decisions about things like this is how substantial is the risk that the defendant's work is essentially going to supplant demand for the original work or licensed derivatives. And I'm going to give you some examples of what I call thick copyrights and thin copyrights, because the way that courts look at them are a little bit different. Some works are highly expressive, and they tend to have a broader scope of copyright. Other works, such as fact compilations and computer programs, have a lot of unprotectable elements in them. And consequently, they have a thinner scope of protection, and courts do more to try to filter out unprotectable stuff in cases involving thin protection. So a scientific article, for example, would be more a thin protection, and a work of visual art might be an example of a thick copyright. So I thought it would be helpful to give a couple of examples. So here is Saul Steinberg's pretty famous cover of the New Yorker, which was the kind of the new Manhattan-like view of the rest of the world. Is like New Jersey's right there, and then the rest of the country, and then the rest of the world, right? So we are the center of the universe is essentially what the message is from that. And this is the movie poster that Columbia Pictures did for Moscow on the Hudson. And the question was whether this was substantially similar to this. Now, you can see that there are a lot of differences. And of course, what Columbia did is try to defend this by saying, different, 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 different. But you can see that there are a lot of stylistic things, right? The font is similar, the sort of layout is similar, the kind of there's some inversion, right? By focusing less on the rest of the US and Asia, now it's focused on sort of Russia. And so the court basically decided this was substantially similar and an infringement. Here's another kind of recent example of something where there's differences of opinion about whether the image on the right, known as the orange prince, is substantially similar in expression to the photograph that Lynn Goldsmith took in 1981 of Prince. In 1984, Andy Warhol made the orange prince. And the trial court said there's no substantial similarity between those two things, because one's really a kind of a totally different type of work than the photograph. And the Court of Appeals for the Second Circuit said, no, they're substantially similar. So exactly what's expression in a photograph is something that's contested. But this is an example where the lines can get a little on the blurry side. There are lots of unprotectable elements in copyrighted works, and I try to list various categories of them. One of the things that I did in the science article, I talked about copyright has a kind of intentionally porous nature, right? We only protect expression, we don't protect any of these kinds of things. And so I thought another illustration might be helpful. So this is one of my favorite cases. Ho and Tavlov were engineering professors at Northwestern. One of them had a guy named Chang working for him. Ho had this as a PhD student, and during the time that he was working as a PhD student under Ho, Ho developed a new mathematical model of how electrons behave under certain circumstances. Chang then went to work for Tavlov instead of for Ho. And with Tavlov, they published a paper and a book chapter about the model, not giving any attribution to Ho or to his graduate student, and using equations, figures, and text from Ho's writings. And Ho's paper about the model got rejected because it had already, the model had already been published by Tavlov and Chang. And so he sued for copyright infringement. I think you can see this was kind of an academic misconduct thing. But is it copyright infringement? The answer is no. So the court basically decided that the model was an idea, kind of an effort to depict a scientific principle. And so it didn't make any difference how creative it was, because it's not part of the expression in the work. And similarly, the equations, figures, and text, which were borrowed pretty substantially from the Ho's writings, were, as a practical matter, there weren't very many ways to say the same thing, and therefore they were not within the scope of protection that copyright provides to that kind of work. And under an old but very famous copyright case, Baker v. Selden, and what's known as the merger doctrine, those elements were not within the scope of copyright protection. So this is a quote from Baker v. Selden, decided in 1880. It has resonance today. So copyright in a work of mathematical science cannot give to the author exclusive right to the methods of operation he propounds or to the diagrams which he employs to explain them, so as to prevent an engineer from using them whenever the occasion arose. The very object of publishing a book on science or the useful arts is to communicate to the world the useful knowledge which it contains. But this object would be frustrated if the knowledge could not be used without incurring piracy of the book. And where the art it teaches, without employing the same methods and diagrams, such methods and diagrams are considered necessary incidents to the art and given therewith to the public, not for the purpose of publication in other works explanatory of the art, but for purpose of practical application. So the point here is that that's the kind of the origin, what we call the merger doctrine, right? So there's just essentially no practical other way to express certain kinds of things. And when it comes to kind of scientific and technical stuff, that's going to be outside the scope of copyright. Now, can generative AI outputs infringe the derivative work right? I think the answer to that is yes. The definition of derivative work in the statute focuses on a work that's based on one or more pre-existing works, And then it gives a set of examples of what might be. So there are 9 examples of things that Congress basically identified as derivative works, and I just list 3 of them here. And then it has an open-ended part, which is or any other form in which a work may be recast, transformed, or adapted. So, you know, can systems infringe? Well, yes, if they produce images or text that are substantially similar to expressive elements in works from which they were trained. So the Silverman complaint against OpenAI has an allegation about the way in which ChatGPT basically produced a detailed summary of her book, and therefore that was an infringing derivative work. And as you can see, condensation is one of the examples of a type of derivative work that might be an infringement. And of course, as we'll hear more about later, training data may contain many copies of works so that the AI model kind of memorizes them. And here's some examples. So Snoopy is probably well known to all of us, and the Schultz family owns the copyright in that. Are these infringements of Snoopy? Well, maybe. Certainly, these were all produced by Midjourney and by DALL-E, so they can be infringements. But I also wanted to raise the question here. Is the person who inputs the prompt saying, hey, I want an image of Snoopy with the doghouse with Christmas lights, is that person the infringer? Or is what about the AI system itself? Are they a direct infringer? I don't think they would be considered a direct infringer, probably, because there's not a kind of human volition. If there's a human volition to bring about that image, it's the person who issued the prompt, not the developer of the model. But there can be such a thing as indirect infringement, so that there's a concern, perhaps, that Midjourney could be an indirect infringer if the user who produces those images are infringers. Then Midjourney might be an indirect infringer, and there are 4 different categories of indirect infringement. The one that's most relevant to generative AI is whether it's called vicarious infringement. Does the entity being charged have the right and ability to control the conduct of users, and do they enjoy a financial benefit from infringement of other people's works? And this kind of right of control and financial benefit is the claim in several of the generative AI lawsuits. Of course, one of the things that the generative AI systems are going to try to do is say, hey, I qualify for the Sony Safe Harbor for technologies that have substantial non-infringing uses. So even if I develop something and I know that some people are going to use it to infringe, it's okay to develop the technology and to deploy the technology as long as it has substantial non-infringing uses. Okay. But in general, the text and images and other outputs generated in response to user prompts will not be substantially similar to expressive elements in works used as training data. And insofar as that's true, then they're unlikely to infringe the derivative work right. Just being based on something isn't enough. You basically have to take a quantum of expression from the work, from a particular work, right? So it could be this much from this work and this much from that work, but you've got to be able to identify particular works in the training set that were the rights of which were infringed. So the Anderson class action complaint includes a statement recognizing that in general the outputs are not going to be substantially similar, and unsurprisingly, the judge, in response to a motion to dismiss, said, out with that one. Now, he gave leave to amend, but they're practically admitting that there's no derivative work right infringement because they want to say that it's because it's the training data is what the thing is derived from, it must be an infringing derivative work. So Getty provides at least one example of what they think is a good derivative work claim. Again, this is an image I showed you before. I think you can see there are lots of similarities. And if you sort of say, are they substantially similar? Well, they're kind of substantially similar. But they're not substantially similar in their expressive elements, right? So the difference in the way that the arms are, the difference in the legs, the various other differences. I think this is unlikely to be an infringing derivative work, but this was the best that Getty was able to do through its for its complaint. So in conclusion, it's important to realize that generative AI is not the first disruptive technology to attract copyright lawsuits. In most of those cases, the challenges have failed. So the Sony decision rejected the Universal's claim that Betamax machines were contributory infringements of the users. MP3 players won a case. Cablevision won about remote server DVRs, but other challenges actually succeeded. The lawsuits that we're talking about today, they're in very early stages. I personally don't find the derivative work or 1202 claims to be persuasive. And of course, I should mention there are probably a dozen other claims in these complaints, but I'm focused on the ones that actually matter, the ones that really are worth paying attention to. So as I said, the training data is the big kahuna. So Mark Lemley gets to talk about that.
I assume there's not time for questions.
We're going to do questions during the joint panel at the end. So, yes.
Okay, it is now my honor to introduce our next speaker, Mark Lemley. And Mark is the William H. Newcomb Professor of Law at Stanford Law School and the director of the Stanford Program in Law, Science, and Technology. He's also a senior fellow at the Stanford Institute for Economic Policy Research and affiliated faculty in the Symbolic Systems Program. He teaches intellectual property, patent law, trademark law, antitrust, and the law of robotics and AI, video game law, and remedies. He's the author of 11 books and 205 articles, including the 2-volume treatise, IP and Antitrust. Please don't read the book. It's helpful for giving people a sense of why you are a qualified authority to speak on some of these issues. Without further ado, I give you Mark Lemley.
Thanks, James. So I come to you as a time traveler from a time before PowerPoint. So I'm just going to talk to you. As Pam indicated, I'm going to talk about training data. This is where most of the lawsuits have been focused so far. It is also, as Pam said, the big kahuna. That's because, for the reasons she indicated, even if it turns out that ChatGPT or DALL-E, right, occasionally generate things or can be prompted to generate things that are substantially similar in output to a particular work, that might create a copyright problem. It might create liability. It might cause you to have to do things and pay some money. It does not mean the end of the entire enterprise. By contrast, if it is illegal to train on any work created after 1928, training is in big trouble, right? Because machine learning depends critically on large sets of training data. And this is true sort of generative AI, but it's true of kind of all kinds of AI, right? If you want good stop sign recognition for your self-driving car, you need a bunch of images of stop signs in different lights from different angles with different trees and things around them. If you want to recognize natural language, if you want to translate, if you want to do speech generation, all those things require sort of understanding and training on corpuses, and virtually all of those corpuses are copyrighted data. right? There are occasional exceptions. If you want to train a database just on stock prices or weather patterns, you're probably fine and you can leave. You don't need the rest of this morning. But if you want to train on pretty much anything else, not just to create images or videos or text, but even if you plan to use anything out there on the internet, that's all copyrighted because copyright is so easy to acquire. In fact, it's virtually impossible not to create a copyrighted work in any given hour of your day. So the question is sort of where do we get that data? The answer, I think, has been some companies, incumbents in other markets like Google or maybe Facebook for image recognition, already happen to have a large database that exists that they can just sort of turn to. Right? People have voluntarily brought us billions of images. If we're Facebook, right? Maybe we could search those. But entrance into the market, anybody who wants to do something new, anybody who wants to go into a new area, needs to either sort of build or license a database. The most common approach, I think, has been to use access to information on the internet. Common crawl, information that people have checked the robots.txt header and said, yes, robots can crawl and index this. Somebody gathers all of that together, then we put it into a training data set. The Lion database of images is built on Common Crawl, right? So here are billions of images that have sort of tag information, so we actually can know in some sense what the image is about. But all of that stuff is out there, even though it's been put on the internet, even though it's been approved using the robots.txt header for indexing, it is still copyrighted material. And one of the things that is most frustrating about copyright law as applied to any computer technology is that you can't do anything with a computer that doesn't involve the making of a new copy. Right? So it doesn't matter that it was already put out there on the internet voluntarily, right? And that they've said, yes, go ahead and crawl it. If you want to build a training data set, you are going to make an internal copy. And because you're making an internal copy of billions of works in the cases of the image cases, or probably closer to like tens or hundreds of billions of works in some of the text data sets, right? The potential for copyright liability is quite staggering if every one of those copies is unlawful. Now, Pam talked to you about the sort of basic principles of copyright law. The one she didn't spend a lot of time talking about is the one I'm going to focus on, which is the fair use doctrine. Right? It is the case that if you are building a large training data set, you are making internally in your computer a copy of an enormous number of copyrighted works. That is kind of presumptively an act that copyright law would forbid, but the fair use doctrine says, wait a minute, there are some times in which it's permissible to make a copy, because that copy serves a valuable social purpose, because it doesn't interfere with a market for the copyright owner or for some combination thereof. And we have a history of cases in what I think are the closest and analogs that suggest that making a temporary copy or an internal copy inside the corporate form for the purpose of generating output that is itself not infringing copyright is likely to be okay. So the closest example, I think, and the closest analog to machine learning is the Google book search case. So Google created a machine to scan physically all of the books in several large research libraries. It created an internal database, and it used it to make a searchable version of book text. It wouldn't give you the whole book text. That would be a copyright problem. But what it would do is give you a small snippet, right? 4 lines of the text, just as it does with any other kind of search result for an internet search. The authors and publishers all sued, and they said, hey, wait a minute, you're making a copy of all of our books internally at Google in order to do this. Court said, yeah, that's true, but that copy is okay because the purpose of this is not to substitute for the sale of the book. The purpose is to have a search engine. The purpose is to give you access to information, to give you something you wouldn't otherwise have had. And you're not interfering with a market that already exists for book snippets. There isn't any market for book snippets. The book publishers weren't doing this. So that case, I think, is an important analogy. There are others. So in the video game cases, video game interoperability in the 1990s, a number of companies decided either, I want my game to work on this platform even though they haven't let me, or I want my platform to run the games from this other platform even though they haven't let me. And in both of those cases, the way you accomplished it was reverse engineering. And in the course of reverse engineering, they took a copy of the entire code of either the game or the game console or both, put it in their internal computer, right? Figured out which parts are actually key, right? Basically reverse engineered the APIs and then developed something that made those compatible. Right? The end product isn't infringing. The end product is our own new stuff, but there's a copy in the intermediate step. And again, the court said that's fair use. That's permissible. It's permissible because the ultimate goal at the end of the day is to generate something that is not itself infringing. So why do I tell you about these? The thing about law, if you are a computer scientist, this is weird. But it is a fundamental thing about law is backward looking. When we find a new question, what we ask is, what is the closest old question that we have already answered that we can analogize this to? And so the way the courts are going to think about these copyright cases is not, let me understand the technology and make a holistic determination of whether it's good or bad, right? Maybe they'll do that, maybe they'll think about it. They are instead going to say, all right, is this closer to the cases that find infringement, or is this closer to the cases that find no infringement? And I think so far, right, the cases, including all the cases I've talked about, have been pretty clear in prior eras of technology that using something internally, making a temporary copy in order to generate something which is itself serving a different purpose is fair use. Is therefore permissible. This is good news if you're in the machine learning world because it means we don't have to shut everything down. Now, some warnings. Past performance is not always a guarantee of future results. This isn't exactly like any of those prior examples. And people will and are arguing, oh no, this should be different. I do think there is we're in the middle of a sort of very large anti-tech backlash. There is, as Pam indicated, quite a lot of moral panic around AI will destroy our creativity, AI will change the world, it will put me out of a job. That might or might not turn out to be justified, but it's driving a lot of people both to bring lawsuits and it's driving a lot of the kind of mindset. And while that probably shouldn't affect judges, it might. So there's a potential risk there. I do think a second thing to think about, one of the challenges that copyright law's fair use doctrine has always faced is if there's a market for this work and I'm displacing the market, well, we don't want to do that. Right? So if in fact people were in the business of selling licenses to train on their data, and I just decided to take it for free instead of paying the money, that's something that's much less likely to be a fair use. Now, there has not, to date as of the lawsuits, been such a market. But you could imagine such a market developing. And I think in the image cases, right, we might imagine if Getty and Shutterstock all say, hey, we're not stop training, do not train on our stuff, but we're fine with training, but we want you to pay us for it. It becomes much harder to say training on those images, but not paying for it is a fair use. Copyright law struggles with how to balance that against the desirable purpose. You could potentially make everything an unfair use by saying, yeah, I don't want you to make fun of me, but rather than say, don't make fun of me, I'm going to say the license for making fun of me is $10 million. And by making fun of me without paying, you have deprived me of $10 million. We don't want the argument to extend that far. And so courts struggle a bit with how to balance the, is there a market harm here without kind of overthrowing the whole thing. So one, I think, of the uncertainties around these cases is, do we see a market develop for training? I'm a little skeptical that we're going to see at least a full market. So I will note here, I am a lawyer in one of these cases. I represent Stability AI in defending the lawsuit filed on training data set. So I have a bias. But one of the things that's notable to me is Stable Diffusion is trained on 2 billion images. Right? So if you were to ask the question, all right, you want to train a data set on 2 billion images, what's the market price for a single one of those images? Now, I don't know, maybe it's $1. But if it's $1, it turns out we've just eliminated the entire market cap of Stability AI. All of the value of the technology has just disappeared, right, to pay the photographer $1. Maybe it's 1/100 of a cent. You could imagine, I guess, a market for, well, I have an image, it's been trained in a database, and I get paid 1/100 of a cent. That doesn't actually sound like a market that's likely to happen, although it might be a more realistic assessment of, well, all right, what's the valuable contribution? We don't have that market yet, but we could imagine, and copyright owners may have a reason to push for there to be such a market. Final sort of uncertainty thing to think about is fair use is a United States law doctrine. A lot of this stuff's going on in the United States, but by no means all of it. And even if you are developing your technology exclusively in the United States, you are probably using it elsewhere in the world, right? Other countries don't have a fair use doctrine. Many of them have some kind of variant of it. So in Britain, there's a fair dealing doctrine, but it's a narrower and kind of more circumscribed thing. Many countries have or are developing specific exceptions for text and data mining that allow you to do this kind of extraction and training, right? Israel has such an exception, Japan, the UK, right? So there are various places in which you can do this thing because it's lawful, but there are also a bunch of countries that just haven't thought about it and that don't have the fair use doctrine and the kind of precedent that we've thought about. So while all the lawsuits have been filed in the United States, because that's where the money is, for the reasons Pam explained, and that's where the lawyers who like to collect the money are. In fact, the biggest legal risks might turn out to be not in the United States, but someplace like India, right, or Europe or China, right, where you have a significant market, but there's not an established legal doctrine that says it's okay to do this thing. All right. I'll just say, I mean, it seems to me that I think the law will, in fact, and it should, conclude that training your AI on copyrighted information is fair use, is permissible. It serves valuable social purposes. I think we get better AI, right? We get less bias. We get safer cars, we get better speech recognition than we would if we have either only things done before 1928, right? Imagine ChatGPT based on trained only on books written before 1928, right? Or a weird subset of, well, you can have the Getty images, but not images of a bunch of other people, and maybe Getty has in fact a very broad representative sample of images of faces of people of all races, but maybe it doesn't. Right? And if we're training on sort of weirdly selected asymmetric data sets, I think we're going to end up with problems. So I think there are good reasons why the law should conclude that this is legal. I think the legal precedent aims in that direction, but it is by no means a sure thing. How am I on time? A couple minutes? Yeah, all right, so I want to say just a couple of things that stray from the training data set and kind of draw a bit off of what Pam was saying and then maybe offer one or two other questions. So the output question is, I think, a harder question for copyright law. Right? It is a much more occasional question. The vast majority of what ChatGPT generates is not similar to any particular infringing work. The vast majority of what Midjourney generates is not similar to any particular image. So it's going to be a more occasional question. But it's still, I think, an interesting and important question, and it's one that the way in which you design your system can have a significant impact on. So if you find an image or a text string that is very similar to one particular input that comes out in the output as sufficiently similar, that's a potential copyright problem. It usually happens for one of three reasons, right? One is overtraining on the same image, right? We didn't actually just take one image and replicate it. We found 1,000 images, which turned out to be 1,000 copies of the same image, and we sort of understood that the machine sort of figured out that there's a kind of constellation of things here, and so if I ask the prompt in just the right way, I can trigger that constellation of things. So you can solve that with better deduplication, right? Second, and I think a harder problem to solve, is the problem of users deliberately triggering infringement. So with Peter Henderson, who's here, and a number of my colleagues in the CS department at Stanford, we did some empirical work in which we found if you ask ChatGPT to write you a children's story about kids who go to a wizarding school, it does not give you Harry Potter or anything significantly similar to Harry Potter. But if you ask it to write a story about kids who go to a wizarding school that begins, and you give it the first paragraph of the Harry Potter book, it will faithfully spit out, with only a few errors, several chapters of Harry Potter, because it correctly understands that the thing the user wants is very specific, and this is the closest analog, right? That's a problem, because it means that users can, in fact, trigger infringement, even if the system is not designed to infringe in the first place. There's an interesting question, I think, about who's responsible for that. At some point, we ought to say, perhaps, hey, this is not a system designed to infringe. This is somebody misusing a system that was designed for something else, and so it's the person who's doing the misusing who ought to be liable. But copyright law is not all the way there right now. And so I think one of the things you might want to think about is, right, can I design my system so that it flags and identifies things of that nature, either prompts that seem designed to generate it, right, or output that is too similar to any one particular input source. Now, those things require compute cycles and time, right? Anytime you're doing something at the back end, right, if you're doing any kind of back end filtering, that's effort. But there may be circumstances in which you say it's worth the cost to me to do that kind of back end filtering. The third example, I think, and the hardest one to deal with, right, Pam talks about Snoopy, right? Why does Midjourney actually, or DALL-E, I think it was, right? Why do they generate such good images of Snoopy? The answer is that the system has correctly identified Snoopy as a category, right? That is, this is not, cartoon pictures of beagles wouldn't give you something much like Snoopy, right? But Snoopy shows up in enough images in the training data set that it has correctly identified it as its own category. Similarly, Baby Yoda. That's usually fine because categories aren't the things you can own, but occasionally where they are cartoon characters or the like, maybe superheroes, the category is also something that there's a copyright in. And so that's just going to be a problem, right? And the people who are most likely to sue, because those are valuable properties, right? The Disneys, the Marvels, the Dr. Seuss's of the world. It might be worth investing in creating a filter that basically says, either don't let people ask about this, right? Or be very careful about what we generate. All right, I'm going to end by noting that one of the things that computer scientists can do that will help is help us to clearly articulate the way the technology works, because there is a lot of misinformation out there. In the Anderson versus Stability case that I am involved in, the plaintiff said things like, well, you know what, it's a collage tool. Right? What we do is we take individual little pixels out of each picture that we train on and we paste them into the new collage. Right? That's of course technical nonsense, right? But it's a way of the court it's a way for the lawyers in the courts who don't understand the technology to try to visualize what's happening. It's a bad way because it misleads, right? But we need good ways. We need to articulate sort of how does this work, why does this work to people who don't actually understand the math behind a stable diffusion technology. And I confess that I'm one of those people. Because if we don't, we're going to get things like, oh yeah, the images are all in the machine. They're all just sort of being copied. They're being passed along. And courts are going to think about things with that incorrect technological assessment, and they're likely to get the wrong result. All right, I will stop there. Thanks.
Great, thanks so much. I believe now is our first coffee break. So if you're feeling sleepy after a lot of talks, you can make your way outside. If you have a poster later today, now's a good time to come up, grab some command strips, and put them up around the room. We'll reconvene at, I believe, 10:30. Am I incorrect? 10:40. See you then. responsive. This is great. I barely started speaking and everyone was already headed to their seats. That's great. I'm glad you all are excited. Okay, great.
Yeah, when you have a critical mass of lawyers in the audience, people follow directions for some reason. So it is my great pleasure to welcome you back and to introduce our next speaker, Miles Brundage. He is a researcher and research manager at OpenAI, where his team focuses on understanding the impacts of OpenAI's technology on society and on identifying ideal policies to recommend both internally and externally based on understanding. His affiliations also at GovAI and CNAS. Miles Brundage.
It's locked out. I might need someone to enter the password. Awesome. Thank you so much. So first, just to give some sense of where I'm coming from and why I'm talking, the context is that I've been involved in a lot of development and deployment of generative AI systems at OpenAI and kind of trying to understand the impacts of them and working with lawyers and machine learning researchers and engineers. So I'm not a lawyer myself. My background is in science and technology studies and technology policy, and I lead an interdisciplinary team that works closely with other teams more with a higher proportion of lawyers. My work and my team's work focuses on understanding the impacts of OpenAI's technology, as James mentioned. So my focus in this talk will be to clarify some things that may not be obvious about how things work in AI development and deployment. Hopefully that will be valuable. And importantly, I'm focusing on the where and the when. So what I mean by that is which aspects of technical systems that are being deployed and when, so which stages of development and deployment are legally relevant. Rather than the how, so not giving any novel legal interpretations, but just trying to understand how the system works. So I'll start with talking about some definitions and concepts about what AI development and deployment actually look like. I'll talk through the history of GPT-4. I'll distill a few lessons from that, and then talk about what to do in light of those lessons. So AI development and deployment are defined in various ways, but roughly what I mean here is building the thing versus shipping the thing. So development refers to design and creation of AI artifacts, including the pre-training and fine-tuning stages, as well as various additional system layers that I'll be talking through later. And then deployment refers to exposing those artifacts to users and applying them to various real purposes. And so the distinctions between different layers of abstraction in AI matter a lot in terms of the legal implications. So I think a lot of the discussion at this workshop tends to be focused on the model level, which is obviously an important one. But one of the points I'll be making in this talk is that there are various other levels of abstraction that are important too. So at the bottom of this slide, you can see examples of models, so neural networks, such as Whisper and GPT-4. And then there are various systems built on top of those models, as well as additional components, such as ChatGPT and DALL-E, and then platforms such as the OpenAI API, and various use cases are built on top of those three things. And typically there are many components to systems and platforms, which tend to be the things that OpenAI is shipping rather than just a pure model. So for example, just to take ChatGPT+, there are non-exhaustively these 6 components, so plugins, i.e. tool use, such as browsing and retrieval, and code interpretation. There's a moderation API, which is basically a content filter. There's Whisper for speech recognition. There's the GPT-4 model, which notably is not the original model, but a fine-tuned version of it. There's a set of usage policies and enforcement processes around those. And then there's a more recent innovation called custom instructions. And so these distinctions matter. And one of the lessons, as kind of a spoiler, is that the legal issues in AI are not all about the base model. And just to kind of illustrate this visually, you can imagine a kind of spectrum of possible social and legal implications of AI, from harmful to helpful. Obviously, this is simplifying a lot. And you could put disinformation campaigns on one end of the spectrum, not very good, and then a coding assistant on the right. And you might think of improving the safety or legality of a specific use case as kind of shifting things to the right. But things are a bit more complex when you talk about an open source model or a broadly capable system or a platform that has a wide range of use cases. And in this case, it makes more sense to think of it as a distribution of impacts rather than a single point on this chart. And you might think of various interventions such as fine-tuning, content filters, use case policies, detection, and enforcement against misuse as doing some combination of shifting the distribution and trying to cut off the kind of tail on the left. The last point I'll make before getting into GPT-4 is that development and deployment are nonlinear. So both within a particular development and deployment cycle and across them, there's a lot of learning that happens and various kinds of feedback loops. So GPT-4, I'll talk a little bit about how it transitioned from a model to a system and a platform and various implications that has for social impacts. So just to give a kind of abridged history of GPT-4, before it was even a thing, people were talking on Twitter and elsewhere about GPT-4 as kind of this meme for AGI or something like that. There were various small-scale experiments to kind of figure out the right hyperparameters to use. There was pre-training that ended in August 2022. There was a lot of testing and red teaming of early versions of the system. There was various steps of fine-tuning that got better and better in terms of different dimensions of performance and safety. There were early commercial testers and users. There was later stage red teaming of more sophisticated versions of the model and the system. We put out a system card, as a term from Meta, and publicly announced GPT-4. We've gradually scaled it up into context, the API platform and ChatGPT+, so a platform and a system respectively. We introduced plugins more recently, which allows GPT-4 as well as GPT 3.5 to use tools. And then today we're at the stage of general availability, but that doesn't mean that we have stopped changing the model or the system. There are continuing efforts to release better and better versions, as well as to tweak various aspects of the system. And in parallel, this wasn't happening in isolation. There was also various things happening in parallel, such as the OpenAI platform we were iterating on our use case policies and content filters, and we also launched ChatGPT, which eventually had GPT-4 incorporated into it. So I think probably a lot of folks here are familiar with GPT-4's capabilities, and some folks may have also seen the GPT-4 system card that we put out, which is a description of various properties of the system, notably the word system rather than model. Because we talk about the various kind of ways in which we were trying to address the model level risks at a system level in addition to tweaking the base model with fine-tuning. So this is a long list, and I'll get back to why the length of the list is important later. But you can imagine a wide variety of use cases, again, the right-hand part of that slide I showed earlier, that are built on top of this model/system/platform. So again, systems and platforms have many layers, often with legal implications that are distinct from the base model. So I'll just give a couple examples. This is from a blog post where we announced the Moderation API, which is basically exposing a good set of content filters that we had built internally for things like hate speech and violent content and so forth, and allowing customers to use it. This is also a component of systems like ChatGPT, where it will kind of like flag certain kinds of outputs as an additional layer of protection on top of the model itself. This is an example of fine-tuning as an additional kind of layer of tweaking the performance of the system as distinct from the original pre-training. So this is teaching the model to refuse a certain kind of request. Here's some examples of disclaimers that are included as part of the system, again, rather than the model. And this is a part of the system that allows users to give feedback and in order to make further improvements. And then finally, the ChatGPT plugin raises a whole bunch of kind of questions around the societal and legal implications of this system as a whole, which are often distinct from the model itself. So just as an example, we recently took down the browsing feature temporarily in order to make sure that we are doing right by content owners. And that is, importantly, something that is distinct from the model. So lesson one, and I think hopefully this has already kind of come across, so not a huge surprise, but it's not all about the base model when it comes to the legal implications of generative AI. Pre-training stage and the base model are important, but they're not everything. Outside of very specific contexts like open source release decisions, the base model is rarely the only thing to think about, and the other components of the system are constantly changing, which means that legal analysis has to be dynamic as well. Just to give two concrete examples of this, so a hot topic in this kind of world is the idea of regulated advice. And so advice for certain verticals like finance and legal and medical. So the point I want to emphasize here is that this is much more a function of things like fine-tuning and moderation and kind of content filters and disclaimers on the kind of interface and use case policies than it is a function of the base model, because basically any reasonably competently trained base model will know something about some of these topics, but that is a different question from whether you are allowing it to be and proclaiming it as a legitimate source of advice on those topics. Another example is language models using tools such as browsing or retrieving from a database. This can both increase and decrease safety and possibly legality in various different ways. The second lesson I want to extract from the GPT-4 case is that David Collingridge was right in the way that he articulated this dilemma in the social control of technology. So I'll just read this quote: "Our understanding of the intersection between technology and society is so poor that the harmful social consequences of the fully developed technology cannot be predicted with sufficient confidence to justify the imposition of specific controls." So that's my wording, because I don't want to suggest that no controls should be done. And by the time a technology is sufficiently well developed and diffused for its unwanted social consequences to be apparent, it is no longer easily controlled. Control may still be possible, but it has become very difficult, expensive, and slow. What happens is that society and the rest of its technology gradually adjust to the new technology so that when it is fully developed, any major change in the new technology requires changes to many other technologies and social and economic institutions, making its control very disruptive and expensive. So I wouldn't endorse that 100%, but I think there is an important insight, which is that comprehensive upfront analysis of all legal aspects of GPT-4 as a system and a platform would not have been possible, in part because many components simply didn't exist at the time that the training was done, and particularly when you think about things like tool use, fine-tuning, use case policies, and so forth, which were adapted in response to how people were actually using the technology. It's also hard to anticipate the best, worst, and most likely use cases of AI systems and platforms in advance. And I think Collingridge was also right about the quote-unquote solution, because his point was that this is just an inherent dilemma with trade-offs, not something that can be entirely solved. But basically, he said that reversibility and iteration are important. And notably, even with an API and saying nothing about open sourcing, it is not trivial to just reverse changes, because people get adapted to the nature of the technology, which I'll touch on in a minute. But nevertheless, there's some sense in which certain kinds of systems can be more easily iterated on than others. And those deploying AI systems typically tweak the parts that are easier to change, both computationally and otherwise. So just to give an example of many use cases being hard or impossible to anticipate, this might have been possible. I'm sure that there's someone on Earth who could have thought of this, but it was definitely not salient to us when building GPT-4 that simplifying surgical consent forms would be a major application. Another example is pre-training versus fine-tuning. So this is, it's just relatively, simple quantitative claim to make that this is just massively cheaper and easier to adjust than redoing the pre-training process. And then the last thing I'll mention is use case policies. So this is just, this is the change log from our website of all the times that we've updated our use case policies. And that is more times than we have trained GPT-4. And another example is system level interventions for responding to bad outputs. So this is an example of a paper that came out just a few days ago. And since the authors had notified us of it, and because we have these various knobs other than pre-training, we were able to address it by the time it was widely discussed. So easier does not mean easy to change. Users and customers might adapt to a system and platform as it is today, and then complain when things change. So just as an example, while I'm not an expert on the details here, my rough sense is that some claims related to GPT-4 getting worse over time have to do with people having adapted to which prompts are most effective for a particular fine-tuned variant, which changes when there's a different variant. So lesson 3 is that the law sometimes provides little guidance for decision making. And so my sense is that there's a pretty wide latitude. Again, I'm not a lawyer, but there's pretty wide latitude in which use cases a company can allow for a certain system or platform. And that's not necessarily unreasonable. It may maybe make sense for governments to support a degree of innovation and experimentation, though, another perspective might be that it's just, there hasn't been much effort yet or successful effort to regulate AI. And there's limited clarity on what is an appropriate degree of precaution across a wide range of risks. And there are a lot of complexities, as we are discussing in this workshop, around IP and privacy, but that is not exhaustive of the areas where there is legal ambiguity. And going back to the list of categories in the system card that I mentioned, I would say that arguably only a minority of those cases are ones where there's even remotely clear kind of legal guidance of what AI developers should be doing. So just to give some additional examples, human oversight of AI systems is something that is very important, but nevertheless, there's not a ton of guidance, either in the kind of policy discourse or in the legal literature on what to do about it. So one exception that I would note is a really excellent paper by Rebecca Krutoff et al., which argues that there are various contexts, such as licensure requirements for practicing medicine, that implicitly require a human loop in certain AI applications, but generally there are much more AI applications than there are cases where there's clear legal guidance, explicitly or implicitly. And the text on the right is from our use case policies, which is an example of not just OpenAI, but various companies kind of going beyond what we understand to be strictly legally required or obviously legally required. Another example is disclosure of limitations of AI models, systems, and platforms, as well as use cases. So this happens at kind of 2 levels. To users, you might want to disclose, for example, that a system can hallucinate, or you might want to train the model to hedge its answers so that it isn't seen as overly authoritative. But this quote here, epistemic humility may inadvertently foster over-reliance, is a quote from the GPT-4 system card based on some of our early user studies, which basically found that some of the things that you might naively, from first principles, come up with legislation saying you must force a system to be humble, can actually backfire in some cases, because sometimes users will be like, wow, this is such a sophisticated system, it's so nuanced. Another level of analysis is the general public. So I think it is reasonable to encourage or require companies to be candid about the risks that they see today and on the horizon. Abstracting away from a particular system sounds reasonable, but experts and companies radically disagree about what the actual risks are, whether these systems understand, whether AGI is a serious thing to talk about, and so forth, and where these things will be in the future. So it's hard, even at that level, to kind of get to a societal understanding of how to think about these things. So just to kind of pull these different lessons together, where and when does the law fit in? I'd say it fits in at lots of places and lots of times in the AI development and development process, not just at pre-training and the base model, though that is important. Though even when it does fit in, it's not always clear what the implications are. And it often fits in ways that are difficult to anticipate when you're building the systems upfront. So what to do in light of this? Some possible implications are that it would be valuable to see a broadening of the scope of some research on the legal implications of AI beyond some of the very important topics that are being discussed here today, including looking at more of the different layers of the system. So for example, things like use cases and fine-tuning, content filtering, enforcement, as well as more stages in the development process, including post-deployment. It's important for regulation to be adaptive as the technology develops. And given that currently democratically elected governments are not giving a ton of guidance in some areas, I think it's incumbent on private actors to at least make some effort to solicit public input so they're not making all of these decisions on their own. I'd like to acknowledge various people at OpenAI and elsewhere who contributed to the work that I referenced here. Lemma Ahmad in particular, who I borrowed some slides from, and Pamela Michigan, Tom Rubin, Katherine Lee, and A. Fader Cooper for feedback on the talk. Thank you.
All right, thank you. We are now going to have a panel discussion of IP issues, and this will also be your chance to follow up with our speakers about some of the issues that they raised. So I'm going to invite over to our panel table Pamela Samuelson and Mark Lemley, who you have already met, and they are going to be joined by Luis Diaz, who is the CEO of Kaiser, and Katherine Lee, your host from Cornell, and moderators for the panel are A. Fader Cooper, who you have met this morning, also from Cornell, and Jack Balkin from Yale Law School. Can folks hear me now? Okay, great. Yes. All right. Great. Yeah.
Okay. Thank you all for being here today, and I'm really excited to get this conversation going. But we're hoping that you'll mostly private once we kick it off, and we're going to use some time at the end for folks to ask questions. And so I thought we'd open it with a question that hasn't actually come up yet in some of the talks. And I know that a lot of the ICML attendees are probably interested in this based on conversations that have happened about AGI and our future AI overlords. And I was wondering if you could talk a bit about the authorship piece of copyright. The authorship piece of copyright. Actually use the microphone. The authorship piece of copyright.
I wrote a paper on that.
Yes, I know. I have read that great paper, and whether you think, how should we think about infringement, or I guess anything that has to do with copyright with respect to potential for machine authorship in generative AI systems?
I want to talk about it, but I think Pam should lead, because she did write about this 35 years ago.
And I went back and read it again, and it's actually a pretty good article. So, it's called Allocating Ownership Rights in Computer-Generated Works. It was published in the University of Pittsburgh Law Review because it was part of a symposium, the first program I ever organized my whole life. And at the time, there was another one of these times when AI got hot. And then, of course, it died down. Of course, it's hot again. But there was actually, my article was one of at least a dozen reports and articles that were addressing these issues. And I thought most of the articles and things were dumb because there were people actually saying, well, the computer should own it. It's like, no, the computer should not own it. And what about the programmer? And what about joint works? Or what about treat the computer as an employer? And it's like, no, this is really a stupid thing. So, so I kind of went through each of the things that people had been writing about, and I said, look, okay, what makes sense is the person who's actually generating the content will actually be able to figure out, is this content that actually it has some meaningfulness that might be commercially viable or that might otherwise, and maybe I'll tweak it a little bit, you know, take out this part because it's not very good, and like rewrite parts of it. And so I was imagining that actually that by putting one's imprint on the thing that the computer generated was going to be enough to basically claim authorship in it. And I think more or less that's not very far from where the Copyright Office is today. But if it's purely computer generated, the office's position, and right now that's being tested in the courts too, is that computer generated images and text and whatever, not protectable by copyright law at all. And if you even try to register something that has both some copyrighted stuff, or both some non-generated stuff and some generated stuff, you have to identify the generated stuff and you have to disclaim. And so the process now of doing registration is pretty complicated. And so that's my 2 cents on that.
And so I think I agree with all of that, but I also think it's not sustainable. I think it's probably not sustainable as an economic matter, right? Because it turns out that if we're going to be generating large numbers of works that would have economic value, there will be a very strong demand for someone to own them, right? And it's free and everyone can make an exact copy of it is going to run up against the first time somebody's actually selling this thing, and I say, hey, I get to make exact copies of it because the computer generated it. So there's going to be, I think, strong economic pressure to try to say, if value, then right. Somebody should own this because it's valuable. I think we should resist that pressure, but it's out there. Second thing, and I think where we will go in the short term, is creativity via prompt engineering. Right. So what we'll say is, well, if I ask a simple question, right, give me a picture of penguins having a picnic on the beach, I'm not going to get copyright in that. That's an idea. Pam talked about the idea-expression dichotomy. But if I come back and I say, but put some mountains behind the beach and make the sky a little redder, and maybe there should be 5 penguins instead of 4. At some point, we're going to say, you know what? My contributions have risen to the level of creativity. And that point in copyright law is very small. You do not need to add much to become a copyright owner. So I think what we'll see is a bunch of people trying to navigate the line that Pam said the Copyright Office set by saying, okay, here's what I have contributed. And that is what it is, but I think it's going to create some real significant problems for copyright law. So Pam told you earlier about the idea-expression dichotomy. The way we've always worked in copyright law is, I don't get to own the idea. I get to own the actual hard work I put in, creative work I put into expressing that idea. I can't own the concept of the painting, but I can own the brushstrokes. AI inverts all that. It turns out now the creative parts are easy. They are automatically generated for me, and so we're going to find ourselves in this weird middle ground where I can't own the idea, but I also don't really have any claim to the actual expression because I didn't generate it, and I'm looking for some creativity at that kind of midpoint level. In part for that reason, we're also going to have some real problems with how we test infringement. So the way we test copyright infringement right now is we say, if your work is sufficiently similar to mine, I bet you copied from me, right? It's unlikely that a song so similar to this Taylor Swift song was developed independently, so as long as you had access to the work, similarity is enough for us to show infringement. That's no longer going to be true. It may well be the case that the reason my picture of penguins at a beach looks like your picture of penguins at a beach is we both asked for penguins at a beach, or we asked the same software, it just sort of randomly happened. It's going to be both harder to prove copying of the prompt than it is copying of the end output, and it's going to be much more plausible that there's independent creation. Copyright law has always said independent, you got to actually copy. But we've kind of not really paid attention to that rule in recent years because we've sort of felt like, oh, right, sufficient similarity of a sufficiently complex system is evidence you copied. I don't think it's going to be evidence you copied anymore, and that's going to blow up the way we think about infringement.
So I'm going to ask a follow-up to this.
Oh, yeah, I've actually got I actually want to push back on something before you ask a follow-up.
Yeah.
So, what I want to, my role up here is I'm the open source guy. I am the guy who has been giving stuff away on the internet for a very long time. And
Introduce yourself again?
Yeah, sure. James gave a very brief introduction. My name's Louis Villa. I'm the, James incorrectly identified me as the CEO of Untitled, I'm actually the General Counsel. And, but I'm also a board member of Creative Commons, which is an organization that provides legal tools for creators. I'm an ex-board member of the Open Source Initiative, which formally defines open source. And I've been involved in a series of open source startups and nonprofits for about 25 years, first as a developer and then as an attorney. And so I've been thinking a lot lately about what it means to do creativity in the open in an age of AI. And I think Mark is correct to call out there's this catchphrase that where there's value, there is a right, the idea that a lot of folks push for that. But I think actually we're going to see, what I wanted to push back on Mark a little bit, we see in the past 20 years some strong pushback on that. First, from open source, we had a lot of people saying, actually, I want to share this, right? I want to give this away. And that actually created an economic, political, lobbying constituency for making it easier to give stuff away. We're starting to see this with the ubiquity of photography. So you've talked about this question, I think, of if we're all taking pictures of the same thing, is there protectable creativity there? I used to be the Deputy General Counsel of Wikipedia, and Wikipedia was actually able to get into European law an exception, not strong enough, but under European law until quite recently, buildings were firmly copyrightable, and so if you took a picture of a building, a famous building, say the Atomium in Brussels, and I use that because they actually tried to enforce their copyright repeatedly. If you took a picture and put it on Facebook of your family standing in front of that building, technically speaking, you were committing copyright infringement of the copyrights in the building. And guess what? Everybody takes pictures in front of these buildings now, right? So you have this new constituency of people who are realizing that the barriers to creativity have dropped, the incentive structure that was necessary, because all of this, and when I went to law school, literally one of my acid tests was, is there at least one faculty member who understands that there may be motivations for creating things other than copyright law? And so I did apply to both of these esteemed institutions. Yeah, I mean, I think because the costs are changing and the incentives are changing, I think that's going to create constituencies that are going to make it more complex. I think 20 years ago, your notion is where there's value, there's going to be a right would have been a very strong guarantee, but I think it's going to be more complex this time around because the economics of all of it are going to change.
This is just a follow-up. I want to go back to the original purposes of copyright law and ask, in the old days, Pat remembers, we imagined a world where there'd be lots of public domain material. There'd be lots of stuff that would be free. And that was thought to be actually promoting the value of copyright. Well, guess what? We are in this world now. We're in the world in which there are lots and lots of things now that will be potentially free. They won't be copyrightable. At least that's the position that's been taken. The question then I want to ask is, what's the right incentive structure for the people who still want to make things? You see what I mean? So in other words, if you're saying it's the prompter who now gets the copyright, right? Well, what kind of incentives do we want to give to people who use AI? That might be the right way to begin the question, as opposed to just, what analogy can I make to an existing system?
Well, I mean, clearly no AI would create if it couldn't get copyrighted works, right? That's what motivates it. So I mean, I think this is a fundamental problem, right, to think about for copyright lawyers, because it does, the technology and the changes in the economic technology do challenge, right, the basic idea of copyright law. And so one response is to say, right, yeah, you know what, there will be a lot more stuff for free. I happen to agree with you on this, right? There are a lot of people for whom, if I can create for free, right, or at very low cost, I don't need an incentive. I am happy to do it. And we've seen that in sort of industry after industry. It's cheaper to make photographs, right? Lots of people make photographs on our phones, not because we get the potential incentive of copyright protection, but because I don't actually have to sort of like make effort. It's cheaper to make music. Many more people release music for free, right? Code and so forth, right? Not everyone, and I think that's an important distinction, right? And that business model can thrive and coexist with a sort of proprietary business model as long as the legal system doesn't basically say, no, you can't have it. But I think one of the reasons we see the kind of current moral panic around generative AI is you see a generation of people in the creative industries who say, oh my God, I'm facing automated competition for free. How do I compete with free? They are not the first people, right, or even the first people alive to sort of encounter this problem, right? We've done it time after time. My sense is that the answer is it works out. It works out in a variety of ways. One way it works out is, yes, it's true that there's a lot of sort of competition from free computer-generated stuff that didn't exist before, but those same technologies also significantly reduce my costs of creation. And so a lot of artists will turn out to be users of these technologies, just as they are users of Photoshop and a variety of other things. And so we saw with music, right? Hey, it's much easier to get music, lawfully or not, right, online for free. But it's also much cheaper to make music. We didn't stop making music. So that's one answer. I think a second answer is if you actually sit down with creative people, they do not create because the incentive of copyright law means that this turns out to be the best way I could generate money. Right? They create because they're driven to create. I mean, you're talking to a group of law professors, right, who the market price of a law review article is $0, but we still write them.
Yours are much more valuable.
Yeah, no doubt. The auctions are great. But I think that's true of a lot of people. Now, that's not a complete answer, right? Because of course, those people have to make a living. If they have to make a living doing something other than taking photographs, that might change the photographs they take, how much time they can devote to it, etc. But it is at least a partial answer to say people will create anyway. And the third answer, I think, is what we've seen in other areas is that there is, in fact, a desire for not just the work, but for the story, for the authenticity, for the human connection. And so we see artisanal stuff coexist with mass-produced stuff in every area of creative endeavor where we've seen mass production, right? And it doesn't, sometimes they don't compete directly, but sometimes it's just it's appealing to a different subset. It's appealing to people who want something else. None of that means there isn't gonna be disruption in these industries. I think there is, right? But it does mean, I think, that the creativity, the sort of human creativity isn't going to disappear as a result of this kind of new technology.
Can I chime in here?
Yeah.
Sorry, passing it along. Wow, okay, so much to grab onto here for discussion. But one thing I do want to also point out is that the way that we see generative AI technology and products being made today is not always the way that they're going to look in the future. It's yet another set of choices that we have. So Mark is talking about creative folks working with these models, and that depends on the UIs that we're able to create and the sort of interactions that we make with these models. So hopefully we'll see that change, and for now, keep an open mind as to what those products will look like.
So I'll mention another couple of possibilities. So one of the things that happened in the 1980s, when there was this last big, wow, computer generated, yada yada, was that the UK passed what's called a sui generis, a little special intellectual property regime for computer generated works. It's similar to copyright, but it's not the same. It has shorter period of exclusive rights, and that's probably an option that will get some attention. And I think that there are people in Congress who are interested in these issues, and so to the extent that there comes to be a perception that there needs to be something, that would be another option. Additionally, we could consider, and I've been a fan of this for a while, what copyright lawyers call formalities, right? It used to be that if you wanted to copyright something, you had to opt in, right? You had to put a copyright notice on it. You had to say, sort of, here's the copyright notice, here's the person who was the owner of it, and here's the year in which it was published. And that was basically opting in. And anything that was actually available to the public that didn't have a copyright notice was in the public domain. As Jack was saying before, we used to think that was a good thing. And so to the extent that there are these vast numbers, I mean, the photographs that we share through social media, I think I actually am pretty good at taking photographs and posting things on my vegetables and things, other things that I really enjoy. But I know they're all copyrighted. And some of them might be commercially valuable, but I don't care. And so another thing actually that's, I think, some creators could take comfort in is that things that are generated by computer are going to be within genre, right? They're going to be based on stuff that already is out there. And so if you're really looking for something that's highly original, that has a kind of artisanal character, in some ways, the people who do real art are going to benefit by, you could get this little thing that was generated by Midjourney. I have to tell you, most of the stuff I've seen that's been generated by Midjourney is like, I would not buy that for anything. So there is going to be still a market for high quality artisanal stuff. And that seems to me, the authenticity issue that Mark raised is also another consideration, it seems to me.
Can I say one more thing on this before we go elsewhere? So there's a very interesting paper in the CS world on ChatGPT that shows that if you train language models on content generated by language models, they basically eat themselves. Right, that the sort of way, the sort of, by not having the kind of long tails of the sort of text of human-generated text, right, training only on computer-generated text sort of actually makes the model unravel and collapse. It forgets things. I have no technical understanding of whether that will turn out to be true across other disciplines besides language. I can imagine reasons why it would. I can imagine reasons why it wouldn't. Right, but it might well be that the computer-generated content will take over everything as self-limiting. I think it is going to be self-limiting in text, but maybe it turns out to be self-limiting in other areas too.
Well, actually, let me follow up with something on that. I think there's a substantial risk of we may have been in a transitory period where much of this sort of public creativity was a shared act, right? Where Reddit, Wikipedia, Stack Overflow, those were not just creativity, but a very specific kind of collaborative, commons-based creativity. As probably some of you in the audience have seen a paper that was last week or 2 weeks ago about the impact on Stack Overflow or at least I thought the methodology is pretty solid on the negative impacts on Stack Overflow, ChatGPT. Wikipedia has not seen that yet, but I think that's a distinct possibility. Reddit seems to be self-immolating for other reasons.
I don't know there are other reasons. I think they're doing that in order to sort of fight ChatGPT.
Well, that's true. That's true. They are intertwined, and so I do think one of the interesting dynamics that we see here is that this is surfacing that over the past 20 years we've had a sort of kind of, we've almost taken for granted that there was a certain kind of creativity that was very collaborative and very public. And if we start asking ChatGPT one-on-one in these chat sessions or Midjourney one-on-one for, hey, I need an image of this sort, that may end up potentially damaging or drying up these commons that we've all been using to do our training, which I think would be a very unfortunate side effect, even if the answers from Stack Overflow or from ChatGPT are better than what we got from Stack Overflow. Like, that's an individually rational discussion, an individually rational choice that's going to potentially cause some collective action challenges.
Can I jump in? Just to add to that, the world of like computer-generated data, computer-generated training data is very big, and so parts of it are, I have no reason to think that image or any other domain would be different from text in this regard. But that doesn't mean to say that there aren't valid uses of computers simply to text. It just means that the way that we do it has to be extremely careful and done. But if you naively do the thing where you just generate it over to text, feed it back into the model, you're kind of distilling and compressing that information and you're losing the tails, like I said. The other thing to keep in mind there is it can also change the distribution shifts. So it can focus more on particular parts of the data than on other parts. So it's not just losing the tails, but also condensing things. And the other thing to consider is we're talking about copyright here, but we should also think about facts and factuality as that relates to releasing information online, especially replacing things like Stack Overflow or Wikipedia. A lot of these generative models don't have any sense of what is a fact.
Yeah, can I actually follow up on that? Because I think there's something to observe out of the sociology of the legal profession, and I'm actually very curious what you all think of this, which is that software law has very often been copyright and speech law, and we've started in the past few years to add in privacy law, but we are suddenly, the combinatorial legal issues in machine learning are just fiendishly complex, and I think the profession is not quite yet ready to, we tend to think of ourselves as a copyright lawyer or a privacy lawyer or a speech lawyer, and being an ML lawyer, I think, is something that is going to be extremely challenging for a lot of attorneys. I don't know if that's something that you all can talk to. I mean, it seems almost sort of, I raised that in part because I realized as I was preparing for this panel this morning that it's almost weird to talk about being copyright lawyers or having just a copyright panel when some of these issues are inextricable. For example, Mark's recent paper cites a paper that's a favorite of mine by Amanda Lewandowski that talks about the role of fair use in combating bias issues in ML. Because it turns out if you train only on public domain stuff, you get a very skewed, very biased take on what's in the world, right? And so you probably need fair use to fight bias issues, but that's not what any of us are thinking about on a day-to-day basis necessarily.
There's a great Saturday morning breakfast cereal from within the last 2 weeks on that very issue.
Yes,
so
indeed.
Look for it if you haven't seen it.
And I think the other thing to note here is that a lot of the stuff is interpretation, how we talk about whether something is fair use is contextual and up to our interpretation. But from a technical perspective, if something is regurgitated or memorized, it's really hard to define exactly what that is. And these aren't necessarily the lines aren't necessarily clearly drawn as we've been kind of circling around. Because something can be generated exactly, but depending on the context, maybe that's okay. If it's a phrase please like and subscribe, or if it's something that's much more specific, then it matters if it's generated exactly.
Can I say, because I think there is a really fundamental tension here between the free speech part, which we're going to hear about right after lunch, and the copyright part. Because it turns out that if the problem we're identifying is the problem of false speech, right, or ChatGPT making stuff up, right, a solution to that is more exact copying. Turns out that's not the solution in copyright law. It's rather the problem in copyright law. And so there's a real tension here between the sort of, do I want my system to sort of faithfully reproduce stuff so it's not going to get it wrong, but is going to be copyright infringement? Or do I want it to sort of generate new stuff which will not be copyright infringement, but might also be wrong?
I want to go back to something that Pam said.
Can I add
Yeah, go ahead.
something? I want to respond to what you raised, which is sort of silos. It's true that a lot of lawyers basically operate in silos. I'm a copyright person. Whatever's happening outside of that area, I just don't know about and I don't care. And I think there is a lot of siloing in the legal profession. But Mark and I, along with James Grimmelin, have also had to get broader because when we started teaching internet law, we had to have a little bit of jurisdiction and a little bit of this and a little bit of that, a little bit of antitrust, a little bit of crypto regulation, a little bit of privacy, and so there is at least a nice strand of folks in our space who actually also know something about the First Amendment. I'm teaching, in addition to teaching copyright these days, I'm teaching a class about regulating and being regulated by internet platforms. That's just a whole nother domain. Now, a lot of the same kinds of questions arise in that context as in the copyright context. And copyright is in some sense a subset of that, because any internet platform has to worry about the copyright stuff as well as other kinds of lawful and unlawful information. So I think there is at least a group of us in the space who actually have been forced to get broader than we might otherwise want.
I think academia is probably better on that than the practice is. Yeah, so I didn't mean that as an attack on all by any means.
Do your best.
Here you go.
Now we're going to go on to question 2.
Do you want to? Here you go. Yeah.
No, do you want to ask?
You
All
go
right.
for it. Yeah.
Another thing that's sitting there is a point that Pam made. There's a distinction between authenticity. I'm sorry, but what I said was worth saying. There's a distinction between authenticity, which is a conception of human connection to other human beings, and originality, which is in other words, the audience says, "Oh, gee, I've never seen that before. That's really original." So one interesting divide this is going to produce is it's going to make a division between what human beings do with respect to each other to form connection to each other through art and creativity, and where people get stuff that's entertaining to them or original to them. So now we're in this world. And the point that Katherine made earlier was that just because right now the stuff that comes out of these systems is not very original or not very exciting or creative doesn't mean that 5 years from now it might not be more interesting and entertaining to lots of people. But that wouldn't solve the problem of human connection, which is one of the purposes that art has. Right? Similarly, the fact that people will still create, even because people like to create, doesn't tell you what the economics of paying for creation is anymore. In other words, it doesn't tell you, do you need to subsidize art creation? Do you need to subsidize people who are artists and that's their profession? So I was wondering whether you had any thoughts about the division between human connection as a function of art and entertainment as a function of art.
Sure, I'll try. Okay, I got this one. Look, I think it's a really interesting question. And so I think one point of art is to promote human connection. And I think it's absolutely right. AI doesn't really do that. Another point of art is to provoke. Right, is to challenge. I actually think AI can do that a lot better than humans can in many respects, right? Because it's going to come from a perspective that nobody has, right? Because it's going to generate something that actually really does make you just sort of think in a way that no one has thought before. Pam said it's going to, it's all kind of like it's in existing channels. I don't think that's true even today, and I think it's going to become even less true. To me, one of the exciting things about generative AI is that it is in fact capable of generating things I don't think any human would ever have been able to come up with. It's certainly done that in the science domains, right? It can look at data patterns and solve problems by just sort of making connections that people don't see. I think it's doing the same thing in the art world. It's true that you're connecting existing things, but if you're connecting existing things no human would have connected, you're giving us something new. That does not, in fact, give you the human connection, and so it's not. I don't think it is a replacement for everything, but I think it's a useful addition to the world.
And what about the economics of creation?
Yeah, my view of this, I confess, is colored by 130 years of history of media technology. Every time a new technology comes around, all of the existing creators tell us that the world will end. There will be no creativity because this technology will destroy it. My favorite, going back to the 130...
No, that's not the point I'm making. I'll make a different point. Let me explain.
Okay.
Let's take your 130 years of history.
The mic for the audience.
Let's take your 130 years of history. In an earlier era, you have an economics of creativity, but it's called dukes and counts and nobles who basically subsidize through commissions. And then you get a democratic conception of creativity, which is democratic plus markets, which basically subsidizes creativity. Now the question I'm asking is not will we go back to dukes and counts and earls, but it seems to me that there's enormous stress being placed on the current model of democracy plus markets as the way that we basically pay for art and make sure that it is sustained.
But I think my argument is still in fact responsive to that, right? So every time these objections have been made, and they start with, so John Philip Sousa was very upset about the phonograph because people weren't going to buy sheet music anymore. They weren't going to sing in their own home. They were just going to listen. It was going to destroy music. Of course, it didn't. And you can go through every technology. But what those technology, we all said, oh my God, it's going to destroy the market. People won't have the democratic creation. It has always done the opposite. It has always made it easier to create and therefore broadened the universe of people who create. And I think AI is going to do the same thing, right? I have no artistic talent, but I can make a painting now, right? Because I now have a tool that will take my concept and turn it into a painting. We've just enormously broadened the universe of people who can create. It does absolutely change the economics. And if your business model was create for money because I am one of the small class who can do that, that business model is challenged. It is under attack. But we've also opened it up to an enormous number of people who couldn't have participated in that market who now can. Every time we've had that trade-off in past technology, it has worked out to our benefit to broaden the universe of people who can create. I think that will be true again, but of course that's a prediction.
I think we need to, okay, sorry. I think we need to talk a little bit about both the people who are using generative AI to create art and also the people who are creating art that's going into generative AI. And like Louise was saying, these are kind of different things. And the talk about human connection, people are posting on Stack Overflow answers because they want to help other people, not necessarily to jump in here. Do you want to follow on that?
Yeah, I do want to follow up on it because I think we can learn something about this human connection point, Jack, from open source software communities and Wikipedia, where Wikipedia is simultaneously a neutral point of view. It's in some sense anti-human connection, right? Because the text itself is not supposed to be emotionally evocative. It's supposed to be a sort of neutral reporting on the thing. And yet there's a huge amount of human connection involved in the creation rather than the consumption, right? And I'm not saying that all art is going to become like Wikipedia, but simply that there will be alternate mechanisms through which some of that need for connection, certainly not all of it, right? Not necessarily in the same way that we all share David, right? But at least some of that, and I think that also speaks somewhat to the economic point. I'm not necessarily as optimistic as Mark is, but we have very much seen new patronage models based on what Dave Weinberger of the Berkman Center used to say, riffing on Warhol, that in the future, everyone will be famous to 15 people, right? And if you can get those 15 people to give you $10 a month, then all this, then you've sort of got a thing, right? And you do have to be, it doesn't mean that now part of being an artist is the performance of authenticity. And that works for some artists and not for others. And I think that's going to be a change. But I think that's sort of, ML is going to have a sort of sidelight to play from that, right? Because I think it's the internet that really does a lot of that now.
Sorry, I'm going to jump in here as well. So, fast back and forth. We have the people who are creating art for the sake of in traditional methods, we'll just say, and maybe that group will be smaller. And then maybe there will be a larger, bigger group of people who are using generative AI to create art. And for some of those people, maybe their goal will be to create some form of human connection. For some of them, it's very, just practical, pragmatic, shall we say. Do you think we will need to have copyright protections for the people who are using generative AI to create that art? And if so, how do you think that should be implemented?
Yeah, so this is the sort of what I was talking about earlier about sort of kind of how will we create copyright creativity for prompt engineering that's sufficiently creative. I mean, I think we probably will go that direction. Do we need it? I mean, I suspect the answer is no. Right, and so I did a paper talking about a paper several years ago called IP in a World Without Scarcity. That talks, it's pre-generative AI, although it's one of the technologies, but there are a bunch of other technologies, right? 3D printing, the internet, right? All of these things that sort of make information and content available, make it easier to create, easier to share, easier to access information. What I think that does is it shrinks the universe of people who actually need the incentive of a traditional copyright system. I don't think it eliminates it, right? And so the legal problem we create is we have, as Pam indicated, right? We have a legal system in which we have all opted in for you with everything you create into this giant copyright system, right? We're probably much better off with a world in which the subset, the smaller and smaller subset of people who actually need and want that incentive can participate in that model, and the much larger universe of people, right, who just sort of want to post their photos to share with their friends, right, or generate the art. My guess is everybody who wants to generate the art doesn't want to generate the art because they want to look at it in the happiness of their own home and just admire it. They're probably going to be sharing it with people, right? But they don't need but I don't think they're going to need the economic incentive to do that. So we might. The question is, how can we align a copyright system that doesn't just say no more copyright, but also doesn't say everybody's got to fit into this box? And of course, Creative Commons is one way to get at something like that.
So a couple of things. One is that people like Chris Casanova, who used Midjourney to generate some images, and then made a book, a small book called Zarya of the Dawn. She wants to be recognized as an author, right? She went to the Copyright Office to register her claim of copyright because she wanted to be recognized herself as an author. And I think Stephen Thaler, who wrote a program to generate images, he generated an image, he took it to the Copyright Office, tried to register it, they rejected it. They issued a certificate initially to Casanova, and then later found out through social media that most of the images were generated by Midjourney. So they canceled the registration, and then there was a back and forth, which was actually about a lot of prompt engineering, and the Copyright Office still rejected the sequence of prompt and engineering efforts as a basis for claiming authorship. But Casanova basically wanted to be recognized as an author. Now, if copyright law says you're not an author, that doesn't mean that the rest of the world can't treat you as an author. And there is this kind of copyright has this particular, this is what we mean by this, and this is what we mean by that. And it is the case that because it's a kind of social phenomena, that it's that we as people can basically recognize somebody as an author, even if copyright law doesn't treat them as an author. And that may be enough, although Casanova keeps trying. They have another application in, and the Copyright Office hasn't acted on it yet. But there's going to be a lot of back and forth with kind of this effort to try to find some little place where that's enough to actually have copyright treat you as an author. But another thing that I liked actually a metaphor of co-pilot, right? So it's obviously a trademark now for a particular code editing tool. But I think it's a good metaphor for the optimistic version of what AI could be. I'm an artist, I want to do some things. I'll use some of these AI programs to generate ideas, to play with some concepts, and then I will use it as some inspiration for something that I will want to create that is something else. But then, if I'm thinking about it as a co-pilot, right, as a tool that helps me, That's different from thinking about it as something that's destroying my field, right? And so if you kind of listen to some of the impassioned remarks of people who are either writers or who are visual artists, they really believe that this is going to kill them, and they're sincere about it. I don't discount their sincerity, but it is the case that that if they get a more positive attitude about it and treat it as a co-pilot, then maybe actually we will all be able to kind of like settle in and find some middle ground.
Well, I really want to jump in there because I think something that two of you have sort of been around the edges of is very relevant to what a lot of folks are thinking about in terms of alignment, trustworthiness in this space in AI. We've tended to, the American copyright system assumes that it is a system of incentives, right? And so we've talked extensively here, like, what are the economics of this? What do we, but there's in the European tradition, the rest of the world's tradition, there's this moral rights notion of even if I have given away everything, I still can't, I have certain inalienable rights because I might actually be harmed if my work is exploited in certain ways. And I think I think we're actually seeing that moment in software right now, where 25 years ago, the open source movement was a very techno-libertarian, we're going to give it all away because how can I be harmed by misuse of my code? Whereas we're now seeing, I think, in this generation of AI developers, a lot of people saying, actually the world can be harmed by my code. I am happy to give it away at no cost, but I would like there to be moral strings attached. And I think part of the challenge that, for those of you who are not lawyers here, I think it's safe to say that every lawyer here has looked at these ethical licenses and cringed, right? Not because they're ill-intentioned, but because but copyright is not, American copyright field is not designed as a tool to make these kinds of ethical judgments, right? And so I wonder, I hear us talking about economics and I hear AI developers talking about ethics and responsibility, but trying to use copyright as a tool for that, and it feels like there's a fundamental mismatch. I don't know how to bridge that, but it feels like that's a cultural gap that's really important for us to
Paul knows how.
Yeah,
sure.
let me just, I guess,
hang on, Mike.
Yeah, just, let me, 1 second.
Okay, I'm dying to intervene on that exact point. I'm Paul, I'm on Team Law, as a scholar. I've never, ever written anything on copyright, and that's the crux of my question, which is, if you're in this room, and this is the first primer on law meets AI you've ever seen, the two things you may be walking away with is copyright deserves private places, the first thing we talk about, and copyright deserves to be 40% of what we talk about. And so this goes to the silo question, which is, do you all want to defend either of those propositions? Because when I think of the list of things I care about, there's 15 things on that list, copyright is one of them. And so part of the question is, why and something I'm asking James the question, why are we spending, I think number one is because we have a lot of law, unlike in privacy where we just make shit up all the time. And then number two is there's a lot at stake. There's a lot of money at stake. But to me, what I'm a little worried about is it's relatively powerful people this second who get paid at the end of the day. And there's a lot of other problems that have a lot of vulnerable, powerless people who copyright does nothing. All right, I wanted to just provoke it.
Well, I want to add and supplement to what you're saying. I think part of the problem, Paul, is that software developers have been told for 25 years that copyright licenses are how you create ethical change in the world. And so at the beginning of this, they started saying like, oh, well, I'm a software developer. I want to make ethical change in the world. Richard Stallman told me that this was the tool we had. And then they turned to literally those same people, right? Like including the open source initiative, and I take some personal culpability for this, turned to these same people and were like, oh, well, you told us for 20 years that copyright law was the way we make ethical change in the world. And then our response as a open source licensing legal community, which is a very real community, it is one of these communities of peers, said, no, not like that. And, but we didn't give them another tool, right? And so I think that's part of the sort of floundering we've seen. I would love to talk some more with you about it. I think it's a great provocation.
So specifically, you're talking about copyrighted laws, right?
I mean, I think people want to copyright everything in part because, I mean,
Outputs?
I mean,
So when we say everything, like inputs, outputs, model.
well, I mean, we have seen in terms of use, for examples that say, oh, and you can't use these outputs for bad purposes, right? We've seen on released nominally open source, a quick clarification, because this has come up in conversation multiple times. Open source software means you can use it for whatever you want. So if a very large corporation tells you that something is open source, but you cannot use it for whatever you want, it's not open source. End rants, find me later with a pina colada if you want the longer version. But yeah, I mean, we've tried to insert that control at every step we can, because we haven't been told what are the forms of control. When people want control, I don't think that's a bad instinct. Or they want it for these ethical reasons, which is not a bad instinct. But we as a legal community have failed to provide other tools.
So I'll give you a history. Pam, actually, you could do this better than I can, but basically in the early days of the internet, the hottest issues were all copyright issues.
Oh, yeah.
And now, once again, the hottest issues are all copyright issues. Why is that? It's not permanent. I think it's temporary because if you went back 5 years ago, everybody's fighting about speech issues, but now we're about to fighting about copyright issues again. The reason why it's copyright, although it is not property in the sense of real property, it is a kind of property-like right, and property is central to issues of governance on the one hand and control on the other. So that if I want to prevent someone from doing something bad, one of the standard ways I do that is by asserting a property-like right to say you can't do this because it's my property. Now, it's often the case that property and property-like rights are very bad tools for governance. They're very bad tools for getting people to do the right thing. But sometimes in a pinch, it's the first thing you turn to, and it's the only thing you think you've got. I'll give you an example. As you get a more mature industry, take social media, for example, this is what I study, what you eventually get is you get a person, Elon Musk, who now uses, not copyright, but he uses control over a platform and control over all the systems, which by the way are based on property rights and other things, to basically get people to do what he wants and not do what he doesn't want, right? But that's a much more mature development of an industry. Right now we're at the very beginning all over again. And so that's why copyright has come to the fore.
Yeah, I think that's exactly right. And if one of you wants to write a paper on that historical pendulum, I will personally print it out and hand it out at every conference I go to, because I do think it feels empowering, right? And yeah.
So because copyright law has the most generous remedy toolkit of any law in the universe, including $150,000 per infringed work statutory damages, okay? The attraction for lawyers to the remedies area is just huge. So, with, let's say, a contract violation, there are lots of limits on damages that can be recovered. So, breach of an open source license, if you can't attach a copyright claim to it, it's worth practically nothing, and you might not be able to get an injunction. Okay, if you just say, well, a breach of an open source license actually means that it's now copyright infringement, then boy, you get this big toolkit. So I think it's not just that it's like the first thing out there, but it's the first thing out there because we've been over generous in the remedy package that comes with it. And given that it applies automatically by operation of law, lasts more than 70 years, or 70 years past your lifetime, and it has very broad exclusive rights. Everything digital gets copied all the time. If you kind of if lawyers look at their toolkit and they sort of say, oh, this is a good tool. And of course, once you do that, it means that that tool, right, is the hammer that you use for everything. One of the things that I've been doing lately is looking at, there are dozens and dozens of lawsuits that have been brought claiming copyright because they want the toolkit, which actually the harm is not a copyright harm, right? So you use copyright to protect privacy. You use copyright to stop breach of an open source license. You use copyright for to stop a critic from doing something that you don't like. And it's just a tool that, you know, it used to be like this little teeny thing over here, right? Here's the big economy, and here's the role that copyright plays. Now, copyright is, shall I say, sort of blossomed, or you could use a cancer metaphor, but you get the point, that it's now a big thing. So courts have actually been pretty good at saying, this may have, you may be hurt by this, but it's not a copyright infringement claim. It's not harm to the copyright. And so there are efforts to kind of like get it like narrower. But again, you can see from these lawsuits, the 10 lawsuits that are out there, boy, the temptation because of the money is just huge.
I'm shocked you're saying only dozens and not hundreds.
So yeah, we have time. We were going to try to take audience questions, but unfortunately I think we only have time for one question. I saw, Corinne, you had your hand up before if you wanted to, yeah.
So speaking of property-like rights, and maybe this will be a bridge to this afternoon, I think for all the reasons we talked about, copyright is not a particularly good match for our main concerns here. But the thing I heard a lot 2 weeks ago in Congress was we're going to change the law in a different way. Copyright, not so much. Publicity rights. We're going to have a federal right of publicity. And so this is open for the whole panel. I would actually just like to know what you all think about that. I think it solves certain problems and it opens a whole bunch of other ones, and we can talk about this separately, but these people aren't here to talk to me, so.
Well, the impersonation, right? The Drake of the Weekend fake music really kind of captured attention, and because you can essentially use people's voices just to say things that they didn't say and sing things that they hadn't sung, there's a lot of concern about impersonation. Now, I think impersonation might be a narrower type of thing than a general right of publicity. So what is right of publicity? Right of publicity is a kind of quasi-property right in a person's name, likeness, and other attributes of their personality. So it's the reason that you can't just take a picture of some famous person and use it as an ad, right? Because you're appropriating their personality. In some sense, you're implying that they sponsor, right? That they agree with your product or something like that. So there's a kind of impersonation there too. But the impersonation issue, I think, is a narrower issue than right of publicity. And so I'm really hoping that when the conversation about some federal right that might be created could be the narrow thing rather than the broad thing.
Yeah. So, right, I think I agree with Pam, right? There is, in fact, a sort of reason, there's a universe of things that we should worry about and prohibit, right? Deep fakes, impersonation, right? That get easier with AI, we want to do something about. Current right of publicity law is a disaster. And because current right of publicity law is a disaster, my first instinct is to say, well, a federal right of publicity law might not be a bad thing so long as it gets rid of the existing current state law. Who knows whether it will. My second instinct is, it's Congress. It's not at all obvious to me that anything they do is going to make things better. It is, you know, in some respects, it's hard to see how they could make things worse than the existing law, but I bet they will have creative ways to do so. So I'm always a little nervous about that. if we had a law that were directed at the specific problem, right, of impersonation and deepfakes, or based on confusing people into thinking you're doing something when you're not, I'm totally fine with that. If it becomes a property right in any image about me, a right to prevent people from criticizing me by telling accurate information or showing embarrassing pictures of the sort of thing I did in public, then I think we have real problems.
I want to, another one of the reasons that many software lawyers reach for copyright instinctively is because copyright this is the International Conference on Machine Learning. You may notice that we've been mostly talking about US law, but copyright is actually standardized by international treaty and has been for 100 years. So you can write a copyright license like the GPL, Creative Commons, that more or less works globally. A right of publicity law, as Mark was sort of alluding to, doesn't even work across all 50 states currently, much less globally. And I think one of the things that's going to be an interesting challenge for practitioners, I really enjoyed the very concrete discussion from OpenAI earlier, because all of these additional legal layers that we're stacking on top of copyright are not standardized across the world and are going to make things, just implementation is going to be a mess in a way that's going to be a real problem for communities, for creative communities, I think, who, at least for this brief window, were like, of course we can operate internationally. And that's going to be very different if we have these sort of fragmented national laws.
And then what's going to happen is that everything though is going to be standardized through terms of service. And so terms of service essentially becomes the law. And that isn't necessarily a good world either.
And I'm really sorry to break this up, but we are a little bit over time. And thank you all for your participation in the panel and for Corinne for your question as well. All right, we'll be back here at 1 o'clock after a break for lunch.
1 o'clock?
Sorry, 1:30. I'm wrong about that. That's not helpful. Thank you. We'll be back at 1:30. Thank you. After a 1.5 hour break for lunch. Very important.
He's the founder and director of the Yale's Information Society Project, an interdisciplinary center that studies law and new information technologies. He also directs the Abrams Institute for Freedom of Expression and the Knight Law and Media program at Yale. He's a member of the American Academy of Arts and Sciences and the American Law Institute, the founder and editor of the group blog Balkinization, and the author of over 140 articles in many different fields, and the author and editor of over 14 books.
Thank you, James. Okay. Hey, guys, how are you today? It's good to see you. Listen, and thank you for inviting me to this. I'm going to talk about first free speech, First Amendment, and AI, but since we're now moving into the privacy section of this event, I'm going to start by talking a little bit about privacy. But I wanted to say that there's now lots of stuff being written on free speech and AI. Most of it is not very good. However, as I was leaving for this conference, Mark Lemley sent me an article written by Peter Henderson, Tatsunori Hashimoto, and Mark, which is fabulous. It's a great article, and it covers most of the important issues, and it's going to be published in the Journal of Free Speech Law. Correct, Mark? Is that right? Yes. So it's great. What I'm going to say is going to overlap slightly with that article. I'll go off in a slightly different direction. But first, I'm going to start in a very different place. When we think about the First Amendment and artificial intelligence, you might think, well, to what extent is artificial intelligence speech protected? That's not where I'm going to start. I'm going to start in a different place. Artificial intelligence systems require huge amounts of data, which has to be collected, collated, and analyzed, and then used, to train models. And so the first place we want to think about the intersection between the First Amendment and AI is, to what extent can the state regulate the formation, the collection of the data, and the analysis and use of the data for purposes of training models and then fine-tuning them. And here I need to invoke an idea which I call the privacy's great chain of being, which is that you can think about privacy regulation as aimed at the collection of data, aimed at the collation of data, aimed at the use of data, aimed at the distribution of data, the sale of data, or the destruction of data. That's the chain of being. We go from collection to destruction. And generally speaking, the First Amendment is most concerned with the back end. That is, with issues of sale, distribution, and destruction. But fortunately or not fortunately, depending on your views on the matter, on the front end of the great chain of being, that is the issues of collection, collation, and use, it turns out that the First Amendment has much less to say. There are some exceptions. For example, you do have a right to record a police officer in a public place. You have First Amendment right to do that, but that's not what we're talking about here. So with respect to most collation regulations and a lot of privacy regulations are regulations on the collection of data and the collation of data, and the most interesting ones are on use of data. And so it's possible to have various kinds of regulations that are, in order to protect personal privacy, that would be consistent with the First Amendment. But I'm going to have some caveats here. So the first thing to understand is that a lot of the data that's being collected is not what we would call personal data. Some of it is, but a lot of it is not. And so you can't use privacy law as a general purpose regulatory tool here, just like you really can't use intellectual property law as a general purpose regulatory tool here. The second thing is that the company might well say the following. It might say, well, look, the company might say, we think that what we're doing when we're training the models and creating the models and using the data, both to train it and then for fine-tuning purposes, we think that that's part of an editorial function. That is to say, we're like a newspaper editing things. So at that point, they're going to claim that they have a First Amendment right to train the model however they want and to tune the model however they want, and that attempts to try to protect public safety or other concerns are forbidden by the First Amendment. So I think that argument hasn't been made yet, but it's just there. It's going to come because a very similar argument is now being used in the context of social media, which is the area that I study, in which the question is there a First Amendment right to program the algorithms for social media any way you want? And so the claim is, yes, that's editorial. That's our editorial judgment. I think, in fact, that the editorial argument is less strong in this context than it would be in the context of some kinds of social media practice, but it's completely uncertain. But I'm telling you, this is an argument that will be made. But what's interesting about this argument, and that's going to take me to the second part of my talk, is that if you're going to claim that you, the company, have editorial interests in the use of data for purposes of training or fine-tuning, then what you're really claiming is that you are the publisher of what the AI produces. That is, you're either the speaker or the publisher of the speech. And that's important for what we're about to turn to, which is the question of the relationship between the speech produced by AI models and systems and the First Amendment. So the first point that I want to dispense with is the argument that people sometimes make, which is, does the AI have rights on its own? And the answer is no, it doesn't. It's not a person, it's not sentient, it doesn't have any of the characteristics that we currently award for personhood that would have free speech rights. And we can talk about that if you're interested, but I think the answer is clear that what we have now is not going to have First Amendment rights. But there is a wrinkle on this, because the First Amendment protects the speech of artificial persons. So for example, churches have First Amendment rights. Churches are not persons. Associations have First Amendment rights. They're not persons. And of course, as Mitt Romney reminds us, corporations have First Amendment rights, right? Corporations are artificial persons under the law. So the argument would be, well, maybe we should treat AI systems as artificial persons. And as artificial persons, they would have First Amendment rights. And I think the argument here is that that's not going to work, for the following reason. The reason why the law treats a church, an association, a company, a corporation as an artificial person for purposes of law and gives it First Amendment rights is that it's a device, it's a social device for collectivities of people, human beings, to basically achieve their ends. So you can, obviously, this is what a church is doing, but if you think about a corporation is a large number of people who organize for the purpose of serving the ends of the corporation, and so the corporation is a tool by which association is achieved. Now, that is not the case with respect to the kinds of artificial intelligence systems that we have today. That is to say, OpenAI, which is a company, that has First Amendment rights, but it makes sense because people organize to do it. But the system produced by OpenAI is not a device for achieving all of the ends of the various folks in the company. So you don't need a legal fiction of treating it as an artificial person. Okay, what does that lead to? It leads to the next question. The next question is going to be, well then, whose rights, which people have rights, and what kind of rights do they have? And also, which people and groups of people are going to be responsible for the harms that are caused? The reason for this is a very basic fact about technology, which is technology is a means of mediating relationships of social power between people, different groups of people. And what technology does is basically it moves things around and changes how people can exercise power over each other. If that's the case, then the question has always got to be, whose rights, who has the right to use this technology and for what purpose, and who has the right to be remedied if there's harm caused? So there are two possibilities here. Possibility number one is that the company, the corporation, the inventor, the first, claims that the AI speech is their speech. Or the person who prompts the AI system, so they want to write a novel, they want to write a poem, they prompt it, it produces information, it produces content, they mix it with their own content, they say, this is my speech. So in that case, in case number one, where the artificial intelligence agent speech is claimed by the company or claimed by a person who gives the prompt, ordinary First Amendment law applies. It's just because we have a human being, they're the speaker, they're using this as a tool, fine. There are some problems because there are going to be various problems involving mens rea, that is to say intention. And so we're going to have to attribute intention. And when I get to defamation in a moment, we'll see this is more complicated to do where AI is involved. The second possibility is a possibility in which the person says, it's not my speech, but the law treats it as the speech of a company. So the classic example is defamation. So in defamation, if you repeat what somebody else says, which is defamatory, the law treats you as the publisher or the republisher of the defamation, in which case you are as liable as the person who originally uttered the defamatory content. But we have a problem, and the problem is in defamation law, as in other parts of First Amendment law, you not only have to show that it's harmful, for example, it's false, and harmful to the person's reputation, but you also have to show a certain degree of willfulness or intention. So, for example, the Supreme Court just decided a case involving threats. And it said that you not only have to prove that the person felt threatened, but also that the person who was making the threats understood that they were making a threat. They had the purpose of making a threat. They knew what they were doing when they did it. So that's a requirement of intention or mens rea. So you can see what the problem is going to be here. I'm a company, I have an AI system. The AI system makes threats. I claim it as my speech because I want the First Amendment right. On the other hand, what is my intention? What is, I don't know what's going on. I know that I might know, in fact, the thing hallucinates. I might know that it issues threatening statements from now and then, but I don't actually have any intention or will with respect to the particular threat involved. And so what we have is a problem when you have the intermediation of an artificial intelligence system, which is engaging in various kinds of torts, various kinds of harms and wrongs, and they in turn depend upon some kind of mens rea. Here's another example. Suppose we have an artificial intelligence system. I claim it's my speech. I'm the inventor of it. I'm the programmer of it. It incites a riot. Well, under First Amendment law, you are permitted to advocate illegal conduct. You're advocated to even advocate violence, as long as you're not directing people to do so with the intent to do so, and it's immediately going to cause that effect. So here, once again, we have a mens rea problem. That is to say, the person who creates it and claims that it's their speech probably doesn't have the appropriate mens rea, even though, in fact, the effect is still the same. So in my view, I think that what's going to happen is we are going to have new doctrines for these cases, because otherwise the incentives are all wrong. The incentives would be for the company to say, oh, that's my speech, right? That is to say, what the AI did was mine. I have a First Amendment right, and you can't show that I have the requisite mens rea, the requisite bad intention, and therefore I'm insulated from liability under the First Amendment. This is not going to work. This is not an appropriate way to organize the doctrine. And if that's the case, then we have to rethink how we're going to ascribe the equivalent of intention or bad purpose in the context of speech by an AI, where somebody claims that the speech is their own. The second case is an interesting case, and it's a case where somebody says, no, it's not my speech, that's just the program. Right? So I either program the thing, I own the company, or I prompt it, and it produces something which is harmful, defamatory, threatening, inciting. But I say, it's not my speech. I didn't say it. The program said it. In those cases, the question is whether the First Amendment would apply at all. We don't have a person who has, a speaker who has First Amendment rights. However, First Amendment doctrine is interested both in the rights of speakers and also the rights of listeners. How do we know this? Well, let's take somebody who wants to read a copy of the Communist Manifesto by Marx and Engels. This was written by people who have no First Amendment rights. First of all, Marx and Engels were not Americans, so they don't have any rights under the First Amendment. They were not in the United States when they wrote it. They were not resident aliens of the United States. They're overseas. They don't have First Amendment rights, and they're dead. Okay? Dead people don't have First Amendment rights. So we know, in fact, that if you have a right to read the Communist Manifesto by dead people who were not Americans, it must be that because listeners have a right to have access to information. So in that case, you might infer that we're going to have this problem that we had before with speaker rights, which is that that basically you're going to have a mens rea problem, where you're going to blame the machine or you're going to blame the system for basically engaging in the threat or the incitement or the defamation, but you can't show that anybody has the requisite intention because the system has no intention. So once again, you're going to have to come up with a different way of thinking about it. Now, there are different possible ways you can do this. Here's one that I have played with, but I'm not committed to. So it turns out that there is an entire body of law, First Amendment law, that is organized for listener rights. It's called commercial speech. Commercial speech is speech which is attempting to sell you a product. It's speech whose purpose is to give you information so that you can decide whether to produce a product. And even though the Supreme Court has basically played around with this doctrine, the justification of the doctrine is not that people have a right, a First Amendment right to speak commercial speech, it's that audiences have a First Amendment right to listen to and get information about goods and services. So it's a listener-based doctrine. Now, it turns out that commercial speech gives you much less protection than ordinary speech. For example, the government can punish false commercial speech. The rules regarding incitement don't apply in the context of commercial speech. So one possibility is to treat the speech of an artificial intelligence system where nobody claims it as their speech as treated under a different set of rules that are specifically designed to deal with listener rights. There are going to be some problems with this, first of all. There are going to be many cases in which we wouldn't want to claim that the mere fact that speech that we receive is false is a reason to ban it, right? And matters of opinion, right, won't be treated by this particular body of doctrine. So it seems to me that commercial speech is not, in fact, the solution to the problem, but it does point us in the direction of a need for a new set of doctrines having to do purely with listener rights in the context of artificial intelligence. There's one last area which I'll close with, and I think it's just a very tiny number of cases. It's a situation in which what we have is speech. Nobody claims it is their speech, but it is effectively part of a product. So the classic example of this would be Google Maps or Waze, which is basically you just press it, you don't have a conversation with it. You say, I want to get to the Hawaii Convention Center, and it basically speaks, and it gives you directions. In that case, it is simply a product. It's not an invitation to have a conversation or a discussion of political opinions. It's just a product. It provides information upon request. In those cases, the law has treated this as an ordinary case of products liability. It has not created any special First Amendment protection. The only problem is that if it's anything beyond that, in other words, if it's an encyclopedia that you consult, or if it's a book that you consult, then in fact the law will treat this not as a simple product. It will treat it as an ordinary case of free speech, listeners' rights. So that third example you see is going to be very minor. So I just want to summarize with what I said before. First of all, in the area of privacy, collection regulations, collation regulations, and use regulations are probably consistent with the First Amendment. You should understand, however, that that is not going to be a complete solution to the issue because much of the data is not personal data. In the context of First Amendment, the central problem is the mens rea problem, which requires a new set of doctrines. And that is true whether or not we treat the AI speech as the speech of a person who claims it is their speech, or whether or not they say, no, it's not my speech, it's just the speech of the system. In both cases, we need a new set of doctrines. The existing doctrines we have just are not adequate to the task. Thank you very much.
Okay, so next session is the spotlights. So I know it's after lunch, you're all kind of, sleepy, but for the next 30 minutes, we're gonna have 5 talks, so it's gonna be going fast. So I'm gonna ask the speakers to please move to that row so that we can quickly switch up. Okay, great, thank you. And we have all the slides here. We'll have 4 to 5 minutes per talk and then 1 minute Q&A. So if you have questions, please come to the mic so that we can quickly, go over the questions and also do the slides. The first speaker is Colin Doyle. Can I? Okay, amazing, great. I have your slides here. Let me just, Ludwig, the whole. Great, okay. Yeah, so we have Colin, and he's going to talk about the restatement of torts. Take it away.
Great, and I just have to go through the slides?
Yes, yeah,
okay,
and I'm
perfect.
here.
Okay, great. All right, everyone, so great to be here. I am an associate professor of law at Loyola Law School in Los Angeles, and I'm excited to talk with you about a project I am right in the middle of right now called the Restatement Artificial of Torts. So the starting point for this article is this idea: large language models seem like they are poised to take over various legal research and writing tasks, but we're at a moment that we're still not entirely sure what are their capabilities, what are their limits. What this article proposes is that we can task LLMs with the project of creating restatements of law and use that as a kind of testing ground for evaluating their performance. So for the non-lawyers in the room, what are restatements of law? In a really quick nutshell, restatements of law are these treatises that are designed to synthesize law from jurisdictions across the United States, create clear, precise legal rules over what the law is. It might seem at first blush that this is just a task of summarization, something that LLMs are good at, but actually it's much more complicated than that because laws are different from jurisdiction to jurisdiction. A legal rule might be the same from one state to another state, but it's worded differently. Or different states might treat these legal rules or have completely different rules for resolving a particular legal issue. And a restatement is therefore both a descriptive project trying to synthesize this law, but it's also a normative one. It's trying to identify what the best rules are to not just state what the law is, but clarify it. Okay, so how do we do that? How can we get LLMs to write restatements? Well, what I've structured here is a process that is similar to the traditional way that a human being would go about crafting a restatement. I start by giving an application a huge number of legal opinions and a topic for what's the topic of this section of the restatement. The first request is for the language model is loop through every single one of those cases and create a case brief, a set of notes of what's the most important information from each of those cases. So that results in a document about this long, way beyond the context window than we could have for a language model. So what do we need to do next? We need to distill that. We then loop through a second time, and from those cases, there we go. From those case briefs, go through each case brief and copy the relevant legal rules and reasoning to this topic. Now we get a much smaller document, still a little bit too long for our purposes of creating a restatement. So we go through another time. We go through all of those rules and we distill them. And we break them down now into a much shorter document. We group those black letter rules together, and we have the language model mark what the trends in the law are, what the majority and minority views are, which rules seem to be clearer, which topics they each address. The next step is it then uses those notes to write a black letter law provision. It goes through a series of steps that are basically lifted from what the American Law Institute that publishes restatements, what they say matters in terms of creating restatement provisions. And the model writes an explanation going through and evaluating 8 different considerations, and then it settles on one final provision for what it articulates as what the legal rule is here. After that, it then goes through all of these notes and it creates a few more pieces. It writes a comment to that rule, it creates illustrations of examples of applying that rule in practice, and it creates a reporter's note that articulates what are the cases from the case law that this was all derived from. And lastly, it edits it for style because the ALI has a style manual, so why not ask it to do so? So how does it turn out? Lucky for me, presenting before you, it does produce something credible. This process of calling on these language models to take these inputs and produce new outputs, we get black letter law provisions that are accurate to the underlying law. We get a commentary that is sensible, and we get reporters' notes that are actually citing to the right cases. That said, it's not perfect. The comments can be particularly generic in a lot of instances. When we have an area of law with a lot of cases, the whole process breaks down. Basically, just maintaining the list of cases occupies too much of the context window, and it completely loses the thread in the process. Both of those, I think, can be overcome with optimizing this process, storing data in different ways, maybe breaking down the structure for creating comments so they become more interesting. But what I'm excited about for these next steps are comparing the artificial restatement with the human restatement. So for the examples that I've gone through so far, where the law is clear, where there's pretty much a consensus across the United States, the artificial restatement and the human restatement produce identical rules. The rules are almost verbatim the same. Where the rules get more complicated, where there are conflicts across different jurisdictions in the United States, we have a divergence. The question here, though, is what does that divergence represent? Depending on the particular context, maybe it's an error in the large language model. Maybe it's an error with how it processed this information. On the other hand, maybe it's an error with the humans who wrote the human restatement. Or maybe both of these restatements are within a kind of zone of permissibility that we could consider when drafting a restatement. Neither of them are disingenuous to the underlying law, but they represent different values and different considerations. Another way to think about this too is there's not just one artificial restatement. We can prompt and prime these language models to have different underlying values for what the purposes of the law should be, and as a result, we can then see what the we can then see the different restatement rules that could be produced when we prime this application with different ideas over the purposes of the restatements and what the rules that it's producing ought to achieve. That's where I am right now. I really would welcome any feedback people have on ideas for directions to go, questions to be exploring and answering here. Thank you.
Great, okay, sorry. Okay, great. Next, we have Shane, who's going to talk about the Data Province project. Also, if you have questions for Colin, you can find him here, or at the end of this, please come to the mic and we can take questions. Thank you, thank you. There it goes. If you want to walk, there's another microphone, but you can just...
Hello, everyone. I'm Shane, and so I'm delighted to present what we're tentatively calling the Data Provenance Initiative, because this is about the beginning of an ongoing project rather than the end of one. And so this is a multi-organizational, multi-discipline effort, including my fantastic collaborators who I'm representing from industry, academia, nonprofits, and legal and open source experts, including Lewis, who you might have seen in the first panel. And what I hope to convince you of in the next 3 or 4 minutes is that we are experiencing a little bit of a crisis in, a crisis in data transparency. So specifically the training data that our models are ingesting. Typically they train on billions of tokens from tens of thousands of sources or more, and thousands of separate distilled data sets that leads us to sort of lose a basic understanding of the underlying data that's going into the models and contributing to how the behavior and the quality that they exhibit. And we're also losing some of the provenance of where this data came from, who created it, what were the intentions of its creation, and how should we maybe respect or think about that in the modern framework in terms of legal and ethical risks and challenges. And so there's sort of 3 ways we think about this. So in terms of transparency, a lot of the data that we're seeing from large corporations is simply undocumented, meaning that the models like from OpenAI and many others, we just don't know what they're trained on to a large extent, but also models like Llama 2 that were released recently and are available for public use. And the issue with this is that we cannot properly audit the risks and challenges associated without understanding the underlying data, including PII leaks, train test overlap, copyright, originality, and many other things. And also the biases and toxicities and maybe Western centricity that is inherent in that data. And just from some of the data sets that I've released or compilations, I've noticed that a lot of the users' training models simply don't know whether their model will exhibit more chatty or terse responses, or whether it will be cautious or uninhibited in the way that it responds, and even mono or multilingual. This information just isn't well understood in a lot of the models that we're training and the people that are training them. And ultimately, this leads to sort of poor quality models. And lastly, maybe the best repository we have for where this data came from is Hugging Face on sort of a large scale. And if we look at it, take a random sample, we found that about 50% of the licenses are either missing or incorrect. But furthermore, there's a lot of confusion in the community about how to use or how to think about copyright and fair use, leading to things like license revisions, lawsuits, of which there definitely will be more, and more to come. And so how are we responding to this? We are conducting a massive, large-scale dataset audit, starting with about 40 collections of collections. And the goal of this is to trace the provenance lineage of the datasets from their text sources to the creators, to the licenses, and to our knowledge, this might be one of the largest empirical analyses of supervised text-to-text data to date, allowing us to understand how people are using, seeing, and maybe not understanding this data. And then we're releasing a series of tools that will help developers to filter by any of the characteristics they're annotating for, including all these provenance properties, download and generate information that explains what is in the data that they are using. So here is sort of a list of where we started. This is a lot of the very popular instruction and alignment tuning compilations of data sets out there, covering a vast variety of skills and abilities, domains, including tool usage, creative writing, and a whole plethora of academic data sets that have been developed over the last 20 years and more. And a lot of these are also generated by models now, including ChatGPT and others. And what we found is that practitioners seem to fall into two categories. They either just train on everything and deploy that commercially or non-commercially, or they are extremely cautious, thinking that every license might hold to them and they might get in hot water or trouble legally or ethically if they don't abide by every license slapped on every data set. But they're also thinking about their risk tolerance with respect to the source of the data, the precedence of use of that data in other models that have been released, as well as the licenses and who created it, whether they're competitors, and what the application is. So this is something that really requires a plethora of information to get to the bottom of. And so we developed sort of a workflow to annotate all this information. Talk to me more after if you're interested. But what we're doing is we're looking not just at the final compilations, but at the original sources of the data, often scraped from the web, the data sets that academics have transformed for machine learning, academics and others, and then the final collections. But if you look at the final collections that are out there right now, you often get very little information. Maybe you hear what languages are in them, the number of examples, and these pie charts that are popular. These are the tasks that they cover. But there's a lot of other information we don't have about the original compilations that you'd have to sift through lots of papers and reading to get to, including their licenses, the creator institutions, the original text sources, whether they were machine generated and by what machine, whether there are human annotators involved, and simple things like characteristics revolving around the domains and the topics. We don't have good information on that. No one's really thought to do this at a large scale and understand, what is in them in more detail, as well as the text metrics, like how long and short the dialogues are, the time of collection, and other sort of useful information. And so I'll just quickly close by saying we are starting, these are ongoing numbers and subject to change, but looking at analyzing all of the licenses, sources, and all this information at a very large level to understand what's in all this, including who's creating all these data sets. And if you'd like to chat more, please come to me and come talk after, especially if you have feedback or critiques, and we're looking for additional contributors. So thank you very much.
Thank you so much. Okay, next we have, sorry, let me get this slide up first. Okay, great. Next we have Ruiji, who's going to present Break It Till You Make It, which is on the limitations of copyright liability in the pre-training paradigm.
Hi, thank you. My name is Ruji. I'm an incoming PhD student at Brown, and this is work that I did with Dylan Hadfield-Manel at MIT. So generative AI and copyright has been getting a lot of attention recently, and one question that has come up again and again in different litigation involving different systems, and that was also discussed today by Professor Lemley, is the question of when is training on copyrighted works infringing? And there's legal scholarship that has explored this question, and these analyses typically focus first on the application of the resulting model. So where that application is considered to be a non-expressive application, such as in facial recognition, the use of data to produce that model is also considered a non-expressive use. And I want to draw your attention to the conceptualization of the developmental process in this proposed test, right? First, there's this application, and the training process is highly related to the application. So because you are producing this model to recognize faces, the training process only takes from like the face, is conceptualized to only take from the face and things like that. And there's only one model as part of this developmental process. And this is similar for the case where we have an expressive application, such as music generation. And the use of music data to produce that model is also considered to be expressive. And this is especially the case where we take from a particular song, say Ariana Grande's hit single, Thank You Next, and it used that song to produce a machine learning model that then generates a song that sounds a lot like hers. Again, in this proposed test, the conceptualization of the system is one that takes specifically from Ariana Grande's creative expression to generate a song that sounds like hers. So we see this decision tree sort of emerge from these analyses. And that's all fine and dandy, but the real world is a little messier. So we're seeing a pre-training paradigm of machine learning development emerge, where there is a centralized group of developers that aim to produce this one pre-trained machine learning model that can then be used toward many different downstream applications. And crucially, this includes applications that are both non-expressive, such as music classification, as well as applications that are expressive, such as music generation. And this is like thinking about a pre-trained model that uses music data. But thinking back to Professor Lemley's talk this morning, right, we can think about a pre-trained vision model. This one training process can be then fine-tuned to improve the safety of like self-driving vehicles by sort of more reliably recognizing stop signs, and that could be considered a non-expressive use. But that very same training process and pre-trained model can then be fine-tuned to generate artistic visual images, right? And this, in addition to the fact that pre-training and fine-tuning is split across several entities, then complicates the evaluation of copyrighted works as part of pre-training and machine learning development as part of proposed judicial tests. And going back to Ariana Grande, we can imagine like a music pre-trained model that takes Ariana Grande's music as part of pre-training. And then one fine-tuner can use that to say, oh, that's a pop song. That's arguably factual and outside the protections of copyright law. Whereas another fine-tuner could use that same training process to create a song that sounds similar to hers. And this sort of complicates liability attribution and allocation when compared to the case that we saw before. This also touches on Dr. Brundage's point earlier this morning about how different architectures different conceptualizations of architectures can introduce different legal questions. And that's sort of the main point of our paper, that pre-training is a core part of the modern machine learning supply chain, and pre-training across multiple entities can complicate the enforcement of copyright law. And in our abstract, we discuss duties of care and potential remedies through fair use and secondary liability, but we're still working on that. So please come talk to me at the poster session so we can work that out together. Thank you to my friends at the Algorithmic Alignment Group and Dora and Peter for all their support during this research. Thank you.
Okay, thank you so much. So next, we are going to have Jonas, who's going to talk to us about diffusion art or digital forgery, investigating data replication in diffusion models. So,
yeah, thank you so much. This is joint work with a bunch of great co-authors who can't all be here, so you have them here on the slide, especially Gautam, who has spearheaded a lot of this effort. So I'm going to talk about stuff from two of our recent papers, and I encourage you to check this out if you want to see more details, especially on the technical side. I'm going to focus mostly on the implications of this stuff in this talk, and not so much on the technicalities. Because in this, we actually want to see, like, they actually multiple questions to figure out, like, do these models copy? There's first a question of the search for the right tools. Then it's a question of, like, what does it mean to actually be a copy? Then how do we evaluate this even? Like we can only evaluate in closed settings, or we can try to evaluate in real world settings. Then we want to ask why these models actually copy, and can we try to mitigate this from a very machine learning perspective, right? So before we do that, we can either check these things on small scale models that we can train on our own, or we can try this on large models that are like some of them like Stable Diffusion. And the interesting thing is that these models do copy. If we just do experiments where we here, for example, we just generate lots of random generations, and now we just check into our database, we do find copies about like some percentage of the time. Where, of course, I said some percentage of the time, but really the thing here is it's super unclear to say like what's a copy, right? Because if you look at this chart here, we actually find copies on the whole spectrum here. These models generate things that are very, very clear copies. For example, you have the Starry Night on the leftmost side of this picture. And you have things that are more in the middle, where it's maybe a copy, and things on the right, which are because only style copies. And really, from a machine perspective, this is just a threshold that we set. But really, there's a much bigger law perspective, like when does it start to be a copy here on this slide, on this chart, right? If we set our threshold somewhere between like the first and second picture, then we find about 1.88% of the generations in Stable Diffusion 1.4 to be copies. And so what do we do with that, right? What do we do about that? How do we move forward? Interesting is, from a machine learning perspective, which I am from, is the question of just what causes replication? What are the effects, where does this come from? And one thing that's very much known in the literature is that this is related to data duplication. If the model sees images several times in the dataset, then it duplicates more often. And you see, for example, in our papers, very clearly there are some setups, for example, where you have like a couch, and then people have put in lots of images onto this couch. They have like, because it's like on a web catalog somewhere, right? So they put different images onto the main screen, and you see that if you generate something, you might get the same couch back, and then a different image on the rest of the thing. Which is also interesting because, right, because often these duplications can be very partial, right? It can be a partial duplication, only parts of the image are duplicated, and other ones aren't. And we have a lot of these variations of this, right? For example, we have stuff like, I'm going to show one example here. We have the moon landing, and if we ask the model for the moon landing, it actually often generates Buzz Aldrin, which you see on the second picture. But here, interestingly, right, like from a more holistic perspective, these really are partial copies. Actually, almost all these are partial copies. They are either semantic copies, or only parts of the image are copied. And in more controlled experiments, we can see that this very, very directly relates to data duplication. The more data is duplicated, the more the model copies. But what we also find is that this is closely related to text conditioning. The more specific a text conditioning is, the more likely the model is to regenerate this image if it sees the same conditioning again. Which means that if you have an image, and it has a very specific caption under the image, because these are all text-to-image generative models, right? If you see the same caption again, you're much more likely to regenerate the same image. And interestingly is that you really see this interplay between both factors, where here I just want to highlight the middle chart, where we see that if we have a data set where we copy both the image and its caption, and we duplicate both things, and as we increase our duplication factor, we see more and more copies, where you see this just chart going up in similarity score. But if we break this apart, if we still duplicate the images, but we train on models where the captions are now varied, and every time we see a caption twice, we actually resample it, with something like Blip, for example, here, which is like a tool to resample captions, suddenly this breaks apart. And here the intuition is almost that some of these captions in these text conditional models work a bit like keys, where if you give the same key again, then the same image is regenerated. But now if the model is trained with multiple keys, then this direct connection is broken, and the model copies less. But of course, these are all just mitigations, really, right? There's from our side, and there's some right from the ML side. There's still a lot of work on like trying to make provable, copy-free things work. And there are a few great preprints out there right now. But for us, these are just mitigations, right? We can do things that if we think this is a problem, then at train time we can do things where we resample captions. But we can even do this at test time. We can actually do things where we. Oh, is there a slide missing? I don't know. Don't worry about it. I think I clicked too fast. Don't worry about it. I'll just talk about it like this. So basically what we can do is that we can, at train time, we can do our resampling. But instantly, is we can already mitigate captioning, we can already mitigate copying for models that are already trained. where we just, at test time, when someone wants to generate an image, we look at their text conditioning, and if we think this might be a copy, then we add a bit of noise to it. So we try to break this direct combination of this caption generates this image. If we add now noise to this caption, then we don't generate this image anymore. And we find, like, empirically that this is already a good mitigation strategy. But of course, in the end, ultimately, this is a mitigation. And there are much broader questions of, do we actually want mitigations? Or will we only accept provable systems that never copy anything? And that might be hard. And that was the question, okay, can we actually have a bit of mitigation? Is that fine if the system is mostly not regenerating the training data? I think this is an open question. Thank you so much for your time. And I encourage you to check out this work for more details.
Thank you so much. So we have our last speaker, and due to attendee request, we are getting an encore from Rudy again. Come, let me get the slides up. The right one, right? Great.
Hi again. I'm here to represent the first author, Stephen Casper, and my colleague to present his paper, Measuring the Success of Diffusion Models at Imitating Human Artists. So this work uses image classification tools from machine learning to better evaluate how well diffusion models imitate human artists. And our central motivation here is to test these approaches and their relevance to legal claims, especially those involving copyright. So diffusion models are getting really, really good at generating artistic visual images. And this is in large part because they are trained on internet scale data, which includes copyrighted works. So on the left side, we have an example image from an artist, and on the right side, we have Stable Diffusion's imitation of the artist, but just kidding, it's the other way around. And how do we evaluate how effectively image generators imitate human artists? And this is an important question because what if an artist sort of submits a claim that this model imitates their work or produces an output that's similar to their work like a legal claim? And there are three ways that you might think about doing this. The two ways are those that exist right now, which is through human judgment. And the problem with that is that it's subjective and it can be difficult to apply consistently. The second way we could evaluate it is using training data. But as we saw before, models are increasingly the result of multiple training processes. And that can be hard to tie the training process with the resulting capability of the model. And so we suggest the use of AI image classification in addition to these two methods alone as a potential way to evaluate how effectively image generators imitate human artists. And we want to emphasize that our goal is not to automate determinations of infringement, but rather to provide another lens through which to analyze these claims. As we saw through Professor Samuelson's talk earlier this morning, two visual images can be similar in non-obvious ways, but in ways that are important and relevant to copyright law. And AI image classification may not be able to tease those cases apart. But yeah, starting on our first experiment, we look at identifying human artists from Stable Diffusion imitations. So we choose 70 artists whose works are in the Lion dataset, which is the dataset that Stable Diffusion is trained on. And our goal is to reclassify those artists based on Stable Diffusion imitations of their work. And we find that 81% of the time, the artist can be successfully reclassified from the Stable Diffusion imitation images. And 69 out of 70 artists were identified in a plurality of the 10 trials. In our second experiment, we look at matching artwork to imitation. So we take an artist's real image, we encode that using CLIP, which is a very common tool in machine learning, and we compare the encoding similarities of the Stable Diffusion between the original work and the Stable Diffusion imitations of the artist and the Stable Diffusion imitations of the other artists. And we use the cosine distance to measure the similarity between those works. And we use a statistical rank sum test to see how similar that artist image is to the Stable Diffusion imitations of their work versus the Stable Diffusion imitations of the other artist's work, and we find results that are statistically significant. So what can we take away from this? Firstly, that tried and tested AI image classification techniques can help us measure the success of digital imitations of human artists. Secondly, this can help us tie questions of copyright liability to the capabilities of a model in a quantitative and consistent way. And finally, Stable Diffusion is definitively successful at imitating the expression of individual human digital artists. And here's the QR code for the paper and the code, and if you have any questions, please talk to Cass. Thank you.
Okay, I want to thank all of our speakers again, and we're done actually with this part. So now we have the poster session. You can find all the posters on the walls. We have the poster sessions till 3, but then from 3 to 3:30 there's coffee break. So if you can actually hold the poster presenters hostage and ask your questions. So that's depending on their cooperation. All of our speakers will have posters, so you can go to their posters and ask your questions. And then we'll reconvene in 3:30, where we're going to be mostly talking about memorization and privacy. So we'll have 2 talks, and then our panel, and then we'll be done for the day. So thank you again for, joining us. Thanks. Yeah, no.
Okay, we're going to get started now. So for the last section, I'm pleased to introduce Carlini, who will give us a brief introduction to machine learning and memorization. Carlini is a research scientist at Google DeepMind. He analyzes the security and privacy of machine learning solutions using classical rewards at IEEE security and privacy, Usenet security, and ICML. He graduated with a PhD from the University of California, Berkeley in 2018. So to kick us off, Carlini.
Okay, thank you. So I'm going to talk very briefly about machine learning and memorization and give a sort of brief introduction to what's going on in this space. If you're someone who has ever read a paper on arXiv before, sorry, this talk is going to be like well below what you're expecting. I'm going to just like really target the lawyers. If you're a lawyer, then great. Hopefully this will be useful for you, because what I'm going to try and do is treat you like, 3-year-olds and introduce you to like what I think is important to like the baseline common knowledge, so that we all have something that's intelligent we can talk about in this space. So yeah, apologies to all the machine learning people. Maybe there's one thing you could take away, which is like the level at which I think you should explain things to policy people, because when machine learning people talk to policy and legal people, they're often very, very into details, and they get nothing useful out of it. And so maybe sort of take this as inspiration for a way to give a talk to people so that some people get at least a couple useful facts out. Okay. I've given this a couple times to a couple different lawyers, so I'm going to say some things to all the machine learning people that sounds really dumb, just sort of like I'm trying to make things as sort of understandable as we can. Okay, so let's get started with machine learning. What is machine learning? Machine learning is a really simple thing that tries to train a model to do something useful. Okay, so let's consider for a moment 2 ways you might imagine trying to become a lawyer. Okay, so the first way, we're going to try and train like a person, a model to do some useful thing. One option is you're going to like go to law school. You're going to like learn from professors. You're going to take exams and study where you got the answer wrong. You're going to talk to your colleagues and like sort of learn in the normal way. Okay, that's what one option. Option 2 is to like find all of the tests you can and just memorize the answer to every single one. Okay, this is 2 ways. Both of them, at the end of it, you will probably be able to pass the bar. But like one of these 2 ways is like actually useful and teaches you something about the world, and the other one is only useful if the only thing you care about in the world is passing the bar. Machine learning models, when we train them to do this second thing. We train machine learning models by showing them all of the tests in the world and asking them to remember the answers to all of them at the same time, with the understanding that when they see a new question, it's probably going to be something similar to what they have seen in the past, and they have really, really good memory, and so they will get the answers right. Okay. So for example, what does this actually mean when we train machine learning models on text? When you train a machine learning model on text, people have said this, I'm sure you've heard it many times before, but it is literally true. The only way you train a machine learning model on text is you show it a sequence of words, and you ask it to state it, sort of to predict what the last blank is going to be. So I say here, like, state-of-the-art models are trained to predict the next blank. And I sort of ask the model what goes there, and the model might say, I think the answer you're looking for is word. And I'll say close, but not quite. I was going for the word token. Because actually models are trained to predict the next token, not the next word, but you get partial credit for guessing the word. And like this literally is like there is no lying going on here. This actually is how machine learning models are being trained. They are trained explicitly to memorize every single document that they have ever seen. Any amount of generalization is by luck alone. Like this is exactly what is going on when you train these models. For images, you have a similar thing here. So if you want to train a model on images, what happens? It's very hard to do like token by token because images are very big. And so the way we train state-of-the-art image models is we take some image from our training data set, And then we add a bunch of noise to this image to get like this noisy version on the right. And then what I do is I train the machine learning model to go from the noisy image back to the non-noisy image. So when we have models trained to like generate really pretty pictures, all the really nice diffusion models you've seen that can generate pictures of astronauts, riding horses on the moon, like all that's happening is it's sort of a side effect of the fact that they are really good at denoising images. And what's going on here is sort of very subtle at a machine learning perspective why it works. None of that is important though. What's happening is we are training these models to take a noisy version of a picture and remove the noise. And so then it makes sense that these models memorize the images, because what they're being told to do is to remove all of the noise. And at some level, there is just no way to know which way to go back to the original image unless you've memorized it. And like, there's all kinds of difficult machine learning tasks that go into making sure these models don't just memorize, but fundamentally, that is what we are training them to do. We are training them to memorize, and any amount of generalization is sort of due to magic pixie dust we don't understand. Okay, so with that out of the way, let's talk about what actually this means in practice. What happens when we train models in this way? As I've said many times now, like training these machine learning models is encouraging memorization, and this generalization phenomenon that we see is mostly by luck. Now, okay, when we say generalization, in sort of intuitively, we like to think of this as sort of some human understanding of generalization. But what machine learning models mean by generalization is something very different. So so the analogy that I've heard Ben Recht give is, let's suppose that you were training to I'm going to learn how to play baseball. I'm going to learn when a particular person is, and so I'm going to go with my parents and they're going to throw a baseball when I'm a little kid, and I'm going to learn to hit the baseball every time. When we think generalization, we think that this means I become good at hitting baseballs. What we actually mean with machine learning models for generalization is that if my parents take me to the same field and throw the ball the same way, I will be able to still hit the ball. We are still asking for a very, very, very constrained amount of generalization. Change the field, machine learning models are going to die. Change the person who's throwing the ball, machine learning models are going to die. But they will still generalize in this one very small way. And so everything about these models is constrained to exactly the data that they're being trained on and the way that they're memorizing this data. Okay, so people for a long time did not understand this in the policy space. So from the EFF, there's a quote that the extent to which a work is produced with a machine learning model, blah, 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 is sort of almost none. There's a similar argument that was made by OpenAI a while ago, that well-constructed AI systems do not regenerate in any non-trivial portion unaltered data from any particular work in their training corpus. And so these quotes are sort of showing where the thinking was around 2019. And we looked at this thinking and we were like, this seems wrong to us as machine learning researchers. Let's try and actually give specific pieces of evidence that it's false. Because we know fundamentally that it should be false, but let's sort of actually give evidence of the examples of this actually happening. And so we went and wrote a paper where we tried to take a state-of-the-art model at the time. This was GPT-2, so it's not nearly as good as the models we have now, but it was the best one at the time. And we showed that if we could give them training examples, or give them sort of random strings, they would just spit out training examples. So here, for example, I care about privacy, not copyright, but it's sort of relevant to all the copyright people in the room. The model would spit out the name, physical address, email address, fax number, phone number of one person who happened to be in the training data set. Why does the model memorize this person? We don't know, but this person got singled out and all of their information is now leaked. Now you might say, GPT-2 was trained on the public internet and so it's fine, but this person had their information out there for one particular purpose. It was attached to some papers they had written and submitted to the government. And it was intended to be used for that purpose, but now the model just sort of leaks it to anyone who wants. And in the same way that all of your information is probably online anyway, it's still doxing you if I go and say here is this person, here is where they live, here is their phone number, and here is this thing that they said that you may disagree with. Like it's sort of like you're making it very, very easy to do bad things. Like this is why we're concerned about these kinds of leaks. Copyright people might be concerned, for example, because the same language model memorizes several thousand lines of code that had some very nice sort of, this one I think was some GPL code or something like that. And it memorized the entire file basically. So this was interesting, and several thousand lines of code is probably not like de minimis. Okay, so this was the state of the world, so circa 2020. We sort of knew that language models would memorize in this way for the reasons that I told you. And then some people come out and say something like, at what point does one person have to accept that reproducing specific images is impossible? Because we all know that images are just completely different, and machine learning models are going to behave entirely differently on images as they do on text. This was some quote from some people responding to the Stable Diffusion lawsuit. And obviously, like you sort of take this as a challenge, and so you take Stable Diffusion. The image on the left is an image from the training data set, and the image on the right is the reconstruction we can do with query access to the training data set, or to the trained model on the training data set. These two images are, for all intents and purposes, identical. They're not as identical we can make them. We can make them a little bit closer. In fact, we can make them so close that the difference between the original image and the reconstruction is smaller than taking the original image and compressing it with JPEG. So if you're willing to accept that compressing an image with a JPEG is still a copyright violation in some sense, then we can extract it from the model with higher fidelity. So it's not like transformative in any way the way the model has done this thing. There may be other stuff going on. There may be fair use and other stuff, but there is here some amount of very, very similar reconstruction between these two images. We can do this for a lot of images. There's roughly 100 of them, where we're able to get the original image, and there's like a nice selection of them here. Okay. So with that, the main thing I want you to take away from this talk is that there are like 3 worlds that you could imagine that we might have been in. You might have imagined that we were in this world where models do nothing but emit their training data. You might have imagined that we were in this world that models sometimes emit their training data, or you might have imagined more in this world where models never emit their training data. And all I'm trying to convince you of in this talk is a very long way of saying that we are not in this first world and we are not in this third world. It's not the case that these models are literally just copying, pasting, collaging images together to form the outputs. It's not the case that models just can never emit training data. It's just functionally impossible. So like the simple legal arguments that I've seen made are just wrong. We're in this very blurry point in the middle where sometimes models emit training data, and whether or not this means that models copy is a question I'm not qualified to answer. But it means that we are in this difficult regime, and I want to make sure that everyone understands that we're in this difficult regime in the middle, and are not going to rely on trying to tell things that they're true when they're not. So with that, that's all I really want to be able to say today. We're in this hard part in the middle, where sometimes models do emit training data, and it's all up to all of you as the lawyers to figure out whether or not this means that they have performed some kind of violation. So with that, thank you. And yeah, happy to take any questions. Do we have time for a question or no? No, panel. OK, no questions.
And we're good. Yeah, so thank you very much for the introduction, and thank you very much for having me here. I am a computer scientist, not a lawyer. I'll just want to make that very clear when we start. Are we good or not? Oh, okay, yeah, makes sense. Cool. So they asked me to maybe see if I can say something about what differential privacy has to do with copyright, and what I did is what I often do. I turned to some of my very smart friends and asked them, what do we think about this question? So basically anything I tell you about today is in joint conversations with many smart folks, including Aloni Cohen, two of our organizers, Katherine Lee, Fatima Merishkala, Siwon Go, Thomas Steinke, and Yuxiang Wang. Any mistakes are my fault. Anything factually wrong is definitely all my fault and not theirs at all. So this is the type of thing that we're here discussing today. Do generative AI models violate copyright? This is a picture from actually Nicholas's slide just a few minutes ago. And for the sake of today, we're just going to say that yes, they do. I know many legal scholars have been discussing this sort of thing, but let's just say, yes, they do infringe copyright. And what can we do about it? How can we potentially save things? Well, let's talk about what a copyright violation means in the United States. It means that the model had access to copyrighted material and there was substantial similarity to something that was copyrighted in terms of what the output is. So there's a number of ways we can address this. One way is potentially to deal with the first one, remove access. So then you would just remove any image that's copyrighted from the training data set. And you might think about this, and this can be a little bit challenging for a number of reasons. First of all, it may not be clear what exactly is or is not copyrighted. So you don't necessarily know what's copyrighted beforehand. You may be kind of conservative. You might say, okay, this may be copyrighted, so let's remove it. And if you do something like this, then maybe you just end up with no training data at all because you have to be very, very careful. Okay, so removing access seems hard. On the other hand, substantial similarity, where maybe we just look at the outputs of the model and say, does this look too similar to any copyrighted image? And if so, then we just don't output it. That runs into some of the same issues as before because it's not always clear what's copyrighted, but there's even more than that because as many examples have been given in the morning, for example, it's not even clear how to define substantial similarity in a mathematically rigorous way or even in any sort of way, really. So it seems like both of these attempts to try to remove one or the other has been failing, and so is there really anything we can do? And what we're going to go with is seeing if we can maybe try to not remove access, but relax what we're going to do there a little bit. So we're going to relax our requirement, and as illustrated just now, that access freeness may be hard to guarantee. It may be a bit too strict, let's say. So in some cases, including when there's no substantial similarity or in cases of fair use. But even beyond that, it might be a little bit hard to guarantee. So instead of access freeness, we're going to try to guarantee near access freeness. So what does this mean to be near access free? It's a little bit of a tricky thing to get your head around, but informally speaking, we're going to say that we want to output some trained model which is close to one which didn't have access to the copyrighted material, but maybe not exactly. So this is an idea recently introduced by Vyas, Kakade, and Barak in a paper at this ICML, actually, in a different context. They don't actually talk about like differential privacy as I will, but we'll revisit theirs at the end of the talk briefly. But yeah, the main idea is instead of trying to make sure that our model does not have access to the copyrighted data, we're going to say that it is close in some rigorous way, some mathematically rigorous way, to one that did not have access to the copyrighted data. So the natural question, is this a kosher thing to do? Is this sort of near access freeness something that would hold up in a court of law? And I mean, my answer is, I have no idea. I can't tell you. I am not a lawyer. But this is sort of, if it would, then this is the idea that we are going to explore. And in particular, it seems like if this does hold up in a court of law, that would be something that allows us to overcome many of the prior challenges. In particular, you don't have to do any sort of hard identification and removal of this training data, which might totally eliminate your training set. You can be liberal with labeling images as copyrighted. So, okay, so far I hopefully have argued to you that maybe near access freeness is something you should do, something that is enough to prevent copyright violation, maybe. So how do you make a model be close to access-free. And I'm going to turn to something called differential privacy, which is a very celebrated and accepted privacy definition. Note privacy, not copyright. We'll talk about the relationship a little bit later. But a privacy definition introduced by Doric McSherry and Seaman Smith about like 17 years ago now. And I'm going to try to give you an idea of what differential privacy is. I'm not really going to give you the formal definition because we don't have time for that, but at least illustrate what it's trying to protect against in a privacy sense. So I'll show you first a cartoon, and then I'll tell you in words what it's supposed to guarantee. So this is a cartoon that I want to show you. Imagine there exists some data set X which maybe has some privacy-sensitive data. We feed it into an algorithm, which is our training procedure for an ML model, and it produces some ML model. Now, imagine instead that we had a data set which differed by just one entry. It was one entry was added, removed, whatever. And that instead was fed into the training pipeline and produced some ML model. Now the idea is some adversary is looking at this ML model, or the output that we trained, and they're trying to decide whether the input was the sensitive data set X or a sensitive data set X prime, which differed in one entry. And if the adversary can't really do much better than random guessing, then we say that the training procedure was differentially private. Meaning, in sort of words that the training procedure is differentially private if the sort of distribution over models it produces doesn't change much when adding or removing one point. So yeah, it's sort of a stability property that things don't change much if we add or remove one data point, including one sensitive data point, or looking a bit forward, maybe one point which we think it might be a copyright violation. So to prove to you that I'm not at least just lying to you and making stuff up, this is the definition, but I'm just flashing it for a sec. Don't worry if you don't know it. We don't have time to get into that. And so for privacy, this is a rigorous and well-accepted definition that has seen use in a lot of places I'll mention. And sort of the open question is maybe what does it imply for copyright? And I'll give you some thoughts on that in a sec. But so differential privacy is very well known in computer science, and it's been used in a number of different places. One of the most high-profile ones has included the 2020 US Census, where it was used on the sensitive data of 300 million plus individuals. If you were in the United States on April 1st, 2020, then your data was run through a differentially private algorithm. And there's a top-down algorithm, whatever that is. It's also used not only by policy or by government agencies, but also by companies. Say Google uses it apparently very recently. Anything you type into the Google keyboard, Gboard, their next word prediction is all differentially private now. So these are some high-profile deployments of differential privacy. So I've kind of demonstrated the definition in this cartoon, but concretely, what does it protect against? If you have a model which is trained via differential privacy, what can we say about that model? And there's many things. For example, it can prevent the regurgitation of individual data points from the training data set. Basically, the problem that Nicholas was mentioning in the previous talk. Determining whether a single point within the training data set or not. This is sometimes called a membership inference attack. Yeah, for example, this can be socially stigmatic if it's a data set involving people who are being tested for HIV/AIDS. Broadly speaking, differential privacy guarantees this very carefully worded statement I put here, which is it prevents revealing any information that wouldn't be present if a particular data point weren't trained on, which is kind of funnily worded, but it's very precise what it guarantees. But really, for the sake of this talk, you can just think of the first one because Nicholas illustrated so well. And generally it provides rigorous and provable, mathematically provable guarantees against these types of leakage in terms of privacy leakage. Good, so that's differential privacy in a nutshell in terms of privacy. So what does it imply for copyright? So let me make the following claim. First of all, I'm going to say that we can train this wording, an epsilon differentially private model P on training data X. Just trust me that I can train an ML model which enjoys these guarantees. I'm not going to tell you how much. I mean, it's a variation of gradient descent where you add noise in the right ways. I can tell you more offline. But one thing I want to highlight here is, as opposed to the previous strategies where maybe you look at the inputs or you look at the outputs, here we're talking about something that actually changes the training pipeline. It opens up the black box in terms of how we train machine learning models. But my claim is, suppose you train a model like this with differential privacy, then we're going to consider any arbitrary copyrighted point lowercase x in the training data. Then my claim is that the model P, which is trained on X, is actually close to one that was trained on the X, the training data set X minus this copyrighted data point. So essentially, this is the kind of near access freeness I was trying to argue about before, that the model that you get out of it will be very similar to one that never had this offending copyrighted image in the first place. Now I say close here, and there's a question of what does close mean? It's quantified. I'm not going to formally define it because that would be a bit challenging in the time we have, but it's something that you can numerically quantify in the sense epsilon defines how close you are to not having access. And in some sense, epsilon, the value of epsilon that you set, which is a number between 0 and infinity, this interpolates between the two extremes which we've already talked, which are familiar to us. For example, if you set epsilon equals 0, this is in some way equivalent to just deleting all copyrighted material and not training on it at all, whereas the standard training that we do all the time is epsilon equals infinity. So this will give you a knob to turn in between those two extremes, and maybe if you said to say like somewhere between say 1 and 10, that might give you a reasonable, provable guarantee of how close the two models would be to each other. So yeah, it interpolates. Again, the big legal question that I don't know the answer is this type of closeness something that a judge would buy? But this has to be tested, I suppose. So that's differential privacy and what it may imply for copyright. There's more nuances. I'm going to highlight a few of those nuances in this slide. One question is, what value of epsilon would be, if any, would be sufficient to prevent copyright infringement? Obviously, if you just don't include the data at all, epsilon equals 0 is sufficient, but maybe a slightly larger version might be. But I'll mention that there's no free lunch here. It's not like, okay, then if you say that, then let's just set epsilon equals 0 and we're good. No, because it's, again, a knob you tune, and the smaller you set epsilon, the more privacy you have. But at the same time, your utility gets worse the smaller you set epsilon. So it's a trade-off. There's no free lunch here that, privacy, you can't get privacy for free along with the utility you enjoyed before. Cool. And then there's also the very difficult question, which I consider not to be a technical, it's not a mathematical question, but what is a point? I said the definition is it's differentially private if its distribution over outputs doesn't change much when adding or removing one point. And it's not always clear what we should define as one point because it might affect what sort of privacy guarantees we have, but also what sort of copyright guarantees we have. For example, if you're looking at text documents, do you have to protect in terms of the addition or removal of one sentence, one document which is copyrighted, or maybe all of someone's copyrighted documents? For images, it's also similarly tricky. Do you just have to add or remove, consider neighboring to be a single image? Does it have to be all images in a series? Maybe all of an artist's creations. For example, Andy Warhol made about 1,000,001 different pictures of the Campbell soup can. Do you have to really remove all of these pictures from your training data set? Or rather, is something which is sort of an amalgamation of 12 of these soup cans, is that something that we have to protect the privacy, protect against copyright violations or not? So these are sort of, once we get some of the establishment that this is actually a meaningful way of protecting copyright, we'd have to discuss, what sort of granularity we need to talk about adding or removing one point to ensure copyright violations don't happen. I'll note that, copyright and privacy are not the same thing. This may be obvious, but some things may violate privacy but not copyright. For example, here's a beautiful piece of artwork I made yesterday, which tells you exactly where I am right now. But if I just tell you this sentence, then this is a privacy violation maybe, but it's not a copyright violation because I didn't copy this beautiful piece of art. On the other hand, there could be things which are copyright violations which are not privacy violations. For example, just outputting the entire text of Harry Potter would be a copyright violation, but not a privacy violation. One thing I'll mention very briefly is there's been some stuff about copying artist style lawsuits, where the top is some artist originals, and then somebody trained a diffusion model on their data, on their artwork, and you can see that this copies their style. So I will say that differential privacy, even if you train this model with differential privacy, it's still possible that it can copy the style because of the fact that the style is kind of not a property of a single data point. It's a property of sort of a collection of data points, which is not sort of specific to one image, unless we set the one point neighboring definition to be like all of an artist's work. However, I'll also mention that differential privacy doesn't protect against this, but also this probably isn't a copyright violation. Again, I'm not a lawyer, but style isn't copyrightable. And actually, a few days ago, a judge seems liable to throw this out because there's no substantial similarity seeming, so that's sort of indicating that that's what they really care about and not the style copy. So I'm just going to wrap up mentioning that, yes, like I want to give appropriate credit to these folks who really introduced the concept of a model being close to access-free as a notion of copyright protection, and they formalize it with a relaxation of differential privacy. That is something which is like less restrictive. That is, differential privacy implies their definition, but their definition does not imply differential privacy, and that gives you more space to design interesting algorithms. But there's some things we can talk about offline. So in conclusion, DP is a rigorous notion of data privacy, and it can be used to argue that a model is close to access-free, not exactly access-free, and it potentially avoids copyright infringement as suggested in our paper by Vyas et al. The last thing I'll say is that this may be difficult to connect to legislation, because right now it's still an open question whether it satisfies privacy legislation, not even copyright problems. So with that, I'll conclude. Thank you very much.
Nicholas Carlini, Miles Brundage, Gautam Kamath, Balkin. This panel will be moderated by Katherine and Ganguli. And there is one additional speaker who I'd like to introduce, Kristen Vaccaro. Kristen is an assistant professor of computer science and engineering at the University of California, San Diego, where she is also a member of the design lab. Her research focuses on the user experience of machine learning systems, particularly around providing agency and control to users. This research has been published in human-computer interaction conferences, including CHI, CSCW, and UIST. She earned her PhD in computer science from the University of Illinois at Urbana-Champaign. Without further ado, our last panel.
For some reason.
Just put this on that table.
Okay, I'll take this.
Okay, great. You hear me? Okay. We're going to start with a very simple, not simple question, which is, and I want everybody to answer this. We don't have to go in order, so you can jump in whenever you want. What is privacy?
Cool.
So they didn't know I was going to ask this.
I know it when I see it.
So Dan Solov at GW wrote a famous article and then a book listing it was 13 different kind of concepts of privacy. Just take your pick. Often people are talking about control over access to information. Sometimes they're talking about questions of manipulation. Sometimes they're talking about disclosure, but privacy is about so much more than disclosure. So I would just say that, and then there's a group of people say privacy about power, you see. So privacy is a starfish concept, right, with different things that are moving out from the sides.
Yeah, I have read various definitions, but I don't want to regurgitate any one in particular that I've memorized, so I will defer to that starfish model.
Yeah, I guess, no, I was only being slightly facetious when I said that I'll know when I see it. I'm not exactly sure what the definition that is that I would want.
researcher, not a machine learning researcher nor a lawyer. So I spend a lot of time talking to actual people about what they have worries about. So we worked on projects doing things like trying to explain differential privacy to people and see, does that actually work? Like, do people kind of understand what exactly is the guarantee that they're getting, and what are the threats, what are the risks that still remain? But I'm also very interested in networked conceptions of privacy, so I do a lot of work on social media, and when you, for example, share a picture of yourself, you're also often sharing a lot of information about your friends, associates, family, etc. And so we have quite a bit of work kind of probing specifically those aspects of you're making privacy decisions not just for yourselves, but for the other folks around you.
Alright, I'm not going to let anyone on this panel off the hook, so we're going to dig in a little bit deeper here. So, in the context of generative AI, what exact notions of privacy do you all, as the panelists, think are more important? Just to give you some examples that I've heard through your talk. Nicholas, you talked about leaking personally identifiable information. That's definitely one notion that we can formalize and talk about. There's also, just as you were saying, Kristen, there's this concept of sort of relational privacy. So what happens if someone steals an image of you and it gets put into the training data, and all of a sudden this is generated. There's also, of course, the deepfake angle, and just to sort of hammer that in, there's a new show on Netflix called Deepfake Love, in which couples are shown deepfake videos of their partners cheating on them, and they're not told that this will happen in advance. These technologies are being used for entertainment and outrage. Already there is no laws. This is a privacy violation. I know that when I see it. So going back to the original question with some additional grounding here, in the context of generative AI, we as a community, what types of notions of privacy should we be thinking of, both from the perspective of the ML and the law?
Do you want to rotate through again?
Yeah, we can rotate through.
Oh, we're going to do this? Well, again, I'm speaking in the absence of all the different ways this technology can be used. The things that come most immediately to mind would be the loss of control over who gets access to information about yourself. So that is to say, if you use a training model, the training model may be based on assumptions about who would have access to information and who would not, right? So in other words, there would be a circle of trust, and then there would be a circle around that, and the training model would completely obliterate these different circles of trust, and then lead to make it possible for people to use information about you in ways that you didn't expect, or uses that you didn't think were reasonable. That's one possibility. The other possibility is not really about privacy, it's really about false light. So this is the difference between privacy and false light, and that's the deep fakes problem, in which you can construct individuals who appear to be certain persons in almost any scenario and also almost any possibility. It also strikes me, though, that the method of collection of the data that's then used for training, in other words, the first stage, if you will, of the construction of the apparatus might be one of the most serious kinds of privacy violations, depending upon how the information is collected. Right. In other words, we might think about privacy occurring at each stage of the creation of an application. We could consider it at the level of collecting the data. We could consider it at the level of how the data is organized and what's left out. We could consider it in the way the model's formed, but we could even consider it at the fine-tuning stage. There could be privacy violations at each stage.
Yeah, I would just build on that and say, in terms of stages, in addition to pre-training and fine-tuning, there's also other relevant senses of privacy in actual deployed generative AI contexts that involve other moving parts. So for example, browsing or retrieval from a private database, and kind of having guarantees and clarity from different companies about what they're doing with various aspects of that data, in addition to training, is also important.
I don't know if I have too much more to add. I guess I'm mainly worried about the data leakage of individual people. Because this is, in some sense, if we can't solve this, like, what are we even doing? Like, there are other things that I guess are bad, but like, this seems like maybe the easiest thing to solve in some sense. Like, at least we have some definitions that would like make things work. And even that like is hard to get people to do good things around. And so I'm sort of spending most of my time like sort of suggesting strong attacks that make this obviously bad. And then once we get our act together and figure that out, maybe we can move on to like the harder things, but I'm trying to focus on the sort of the easiest thing first.
Can I just follow up with what you just said? So vulnerability, you just mentioned what I thought, vulnerability to attack by various folks once the application is up and running might be an independent privacy problem. That is to say, it's really, we wouldn't call it a security issue. I mean, that's what we talk about legal. It's a new kind of privacy problem that's created by the existence of this particular kind of application.
Can I jump in?
Yeah.
So I'm kind of curious, I'm going to circumvent the going around, but we kind of talked about like, is generative AI different than, say, for example, just data collection or like search, like the example that you showed, Nicholas, like how bad is that really if like I could just go onto Google and search for someone's name and find out their contact information? Is generative AI in some way worse?
Yeah, okay, so the reason why we write our papers on models trained on the internet is so that we can write them and not actually violate the privacy of individual people. Right, like it would be everything that we do with the models that are trained on the entire internet, we could have done on models trained on like hospital medical records, but like I'm not in the business of like violating the laws of like, you know, not disclosing medical records to like everyone on the internet. And so the main thing that I think we should take away is what the impact was, like could have been, if this had been trained on something different. So I would argue it was bad in the first place that this person's information was leaked, even though they were already trained on the public internet. But it would have been many times worse if this model was trained on all of your private emails, and then it happened to leak one of them online. But I'm not going to go and actually do that. And so we should like take the understanding that like the best attacks that we have are the attacks that we have and also can publish at the same time.
I'll just briefly add on the point about like comparison to search. I think it's important to kind of compare things not just at the model to search engine level, but also like deployed AI system to search engine level. And you can imagine various kind of like filters. For example, with ChatGPT, we teach it to refuse certain PII requests. So that's kind of an example where the exactly what you're comparing matters.
Did you have anything?
No.
I was just going to add one thought that I had. I mean, obviously, I think I answered already. I'm very interested in networked privacy concerns. But I was going to add about the input data question that I felt like a question I really still had at the end of this morning's panel was this issue of the power dynamics between the various players in these systems, right? So like, obviously I spend a lot of time working on social media. People post things, as we were talking about this morning, people post things on social media with a certain expectation about how they're gonna be used, right? My primary intention is I wanna share my trips to Hawaii photos with my friends and my family. And I may have an understanding, okay, Facebook is also gonna do some targeted advertising. They're gonna show me some, restaurants that I might wanna go to, or like a new bathing suit I might wanna buy. But I kind of have some expectations, right? I think often talked about as contextual integrity for how this information should be used. And I think part of what makes generative AI feel different to people is that you have this sense of kind of a larger scale creation coming out of the work. This data that you're generating for these companies, I think that is also part of why people are so mad on Reddit, which I would love to talk about with folks at some point if there's a good opportunity. But yeah, that's my thought about the kind of input pace that you were talking about.
Yeah, and just picking off that, yeah, like I think that right now we don't really have an idea of how these models are trained frequently. Like there's very mysterious thing that they say using a combination of public sources, and then there's another thing that says like data obtained from other sources, which are very, very vague. And I don't think we really have an idea of, did I agree to something? Did I inadvertently, scroll down, click accept, and now, my personal data is in whatever big model? That's something that we don't really know, and I think that's a kind of a problem there, but also a problem, I think, with how we usually treat these, I think everyone, I don't know how many people actually read the entire terms of agreement whenever you click accept for those things, but I think now the default is that people just don't, and they think, okay, things will be fine. But I wonder if maybe in the age of these large generative AI models, then maybe things won't be fine. Maybe we see the consequences of these, which have been lurking for so long.
Miles, you want to comment?
Can I just ask a question about the current state of the art? Based upon, in terms of strength of inference. Let's say that we've trained a model based on as much stuff as we can get. And then I take a picture of this gentleman here. I put in his name and his picture, and I tell you a few things about him. And then I ask you to give me a prediction of what his medical situation is, what diseases he might have. I can ask also all sorts of intimate things about him. To what extent is the model able to make plausible predictions about these kinds of things which we ordinarily would consider matters of privacy? Now, of course, if it hallucinates and just says, well, I think he has the following diseases, that's a defamation problem. That's a problem of false light. But I'm interested in the question of plausible predictability.
And I would just add that there are relatively simple cases, scare quotes of privacy where it's exact memorization. I think some of the trickier things around reasoning and inference, and I've said this repeatedly today, but thinking about it at a system level where you think about what kinds of inference could be drawn from a generative model combined with search, combined with retrieval and so forth is a different question.
To try to answer that question, I guess my current understanding of the best things was let's just pick on me and say so you feed in a picture of me, tell name, demographic, stuff like that. I could imagine that it would be using maybe large demographic things. For example, he's of Indian descent, so maybe that high risk of diabetes, but he's also relatively young, so maybe not. But I think specific things about me, Gautam Kamath, then it would probably be making up rather than having his database. But also, I'm not that public a figure, so who knows? If you put in a picture of Lady Gaga, maybe they'd have that right there.
So that's really one of the possible future problems. To the extent that if we give enough data points about an individual, which don't seem on their face to be about intimate details or private details, and from those we can infer, because of course you always are squealing on your relatives and friends and people you deal with, right? Then we really do have a privacy problem. And it's a privacy problem not because of disclosure, but because you've been able to infer sensitive information about a person.
I just want to kind of expand upon that. So sometimes, so I'm in the business of building these large language models, and oftentimes as someone who's also not a very public figure, I ask, who is Deep Ganguli? And early on, it would say, I don't know who that is, and I also don't know anything about anyone who works at Anthropic. Is this a violation? And so I can give one more example of this. These days, it says, oh yeah, he's a professor at Calcutta University, which my last name is a Brahmin surname of people from Calcutta. It is inferred that I do some sort of research. I'm always either an electrical engineering professor or a computer science professor. I'm of course neither. So I'm curious just to can you expand on is this a violation of privacy? How should I think about the model?
Well, it's interesting because when we think about privacy, we ordinarily think about there's information somewhere. It's given to a person, a trusted person, say a doctor or something, and then it leaks out beyond the people who were trusted with it, right? In other words, so it's not that somebody doesn't know it, somebody does know it, but the wrong people know it, right? And they use it for an inappropriate purpose. That's often what we mean when we're talking about privacy. It's about who you trust, what's an appropriate use, and what's an inappropriate use. It's not that the information is completely secret, it's that it's within a particular circle of trust. Okay, but suppose I could generate that information without betraying without any individual leaking it or disclosing it. Suppose that simply through different pieces of information that are gathered about me, a program could in fact infer these things and infer it with a high degree of accuracy. I mean, we have early versions of this in terms of diagnostic equipment, right? where we show pictures of particular parts of the body, and then you'd get as a prediction as to whether or not there's a problem. That's really, it would seem to me, the new thing that generative AI might be able to produce in the future, which would make it quite different from search. In search, you just find stuff that's available somewhere. Here, you're actually generating predictions about the nature of individuals, and then once you can do it for one individual, you can do it for lots of individuals. But we're not there yet, I take it. We're not even close to that world.
Sorry, we'll come to you right after. This kind of reminds me of recommendation algorithms, where some of the conversations we have about that are like, if I look at your product recommendations and you buy this, product that's very typical of a person who engages in this particular type of hobby, and maybe this collection of products that would be kind of rare to buy in combination unless you participate in this particular type of hobby or of the art of this particular demographic group, that can make a certain inference about who you are. And any one of those, any individual product that you buy might not lead someone to that inference, but collectively you have that information.
We already have that with respect to political behavior. So in other words, we can tell with a great deal of certainty whether how somebody votes, just from basic stuff they buy and sell.
Yeah, like I think the interesting thing is that, this is, let's start with a very simple case. Suppose you go and see someone who's smoking a cigarette, and you see them smoking another cigarette, like you realize they're a chain smoker, and you say to them, which is weird, but you'd say, hey, I think you might have cancer in the future, and like maybe predict correctly. Is that a privacy violation? Like, because the thing I'm trying to say is this is a scientific fact that people who smoke are more likely to develop cancer. So that's a very simple inference you can make. Now, the thing about machine learning models, they don't just use these very A to B, A implies B type things. They use signals from 12 billion different things and somehow maybe can make complicated inferences. And maybe from that, they figure out something that is sensitive about your medical history or something like that. Now, just because this is so much more complicated, does it somehow become a privacy violation now or not? This is, I think, I'll say that I'll mention this with respect to differential privacy. This isn't something you guarantee, and this is like a big tension sometimes in the community, because sometimes people write academic papers saying differential privacy doesn't protect this, and indeed it doesn't, because it doesn't protect things that we call science or machine learning. In some cases the solution here is just not to do machine learning or science at all to discover these relationships. And whether that's a privacy risk or not is unclear. Depends on your definition of privacy.
All right, riffing off of the recommendation example as well, like how should we think about malicious access versus incidental access? So Nicholas, you talk about like actively in the context of security, modeling an attacker, yet more recently we've been talking about, we can just maybe sort of infer things about people, and so in the context of generative AI, is this a useful distinction of which to think through issues around privacy?
Yeah, I definitely think it's interesting because you can have, supposing that I had a model that I asked, who is Nicholas Carlini? And it then went and revealed all kinds of private information about thee. This would be much worse than a model that I had to very, very carefully craft some special input to get it to expose this one piece of information that it has, right? The degree to which it is easy to cause this leakage significantly sort of complicates the situation around, like, is it like how bad it is? Where, and we had some discussion around this earlier around copyright also. If a model leaks copyright information only when requested to adversarially, who is to blame, is very different than a model that just 1 in 100 times just starts quoting some copyright book. And so I think it is very different sort of qualitatively. I think fortunately it is significantly easier to solve the case where the privacy leakage occurs just on average. RLHF does a pretty good job at that, just training the model to not emit training data on average. I think the much harder case is preventing it in the targeted case.
I would just note that this is connected to Katherine's point about like what is the comparison. Like, you know, there might be a point at which like there is a sufficient degree of effort required such that it doesn't make sense anymore compared to just Googling it or something.
I mean, it's not really Googling it a lot of times, right? Like, there's a market for all of your data out there. And so I think the question is, like, if these generative models at some point became cheaper than buying the data directly on this market, then you might have to worry about it. But I don't think that's true yet.
So in the US, privacy law is kind of, but the question that I have, and maybe you can answer this, or maybe you can as well.
Those are my two choices.
Yeah, sure you have more, but I'm just anticipating. In the case of like, if it's maliciously accessed or like incidentally accessed, how does that change how you think about like the legal analysis here? Or like, should this model be trained? Should this be outputted? What sort of mitigation should we put into place? These sorts of questions.
Well, obviously, if you're, with these models, you're interested not only in accidental disclosures of information, but also vulnerability to bad actors, right? That's what you're trying to do. So I take it that if you know there are bad actors who are constantly trying to use a powerful system in order to get sensitive information, you have some responsibility if you don't, fine-tune them to avoid that. I was going to ask this, but I'm going to ask this question. Let's suppose I want to make some money off vulnerable individuals. This is kind of privacy, but it's where privacy slides into consumer protection. So I know there are a bunch of people out there who are idiots about their finances, and they will buy, coins that are worthless and think they're valuable, and they'll buy special mortgage products that they think will be good for them, but which actually be quite bad for them, and any number of different financial instruments that will promise them that will in fact soak them. I would like to use these large language models to identify these people so that I can target them and sell them these products. Do we have the current capacity to do that, or will we have that capacity soon enough? So this is where privacy slides into consumer protection.
I feel like really one of the ML folks should answer this, but like we don't need generative models for that. You can just do this with a normal old-fashioned machine learning, and yes, like you can buy lists of people like that. Like you can buy lists of people with depression. You can buy lists of people with drug abuse habits. Like you can buy lists of people that target all kinds of vulnerable attributes and yeah, make lots of money harming them. Like that is the surveillance capitalism economy.
So then the question I'm asking is, if we already have these capacities to some degree, they're not perfect, can these new technologies make it easier, cheaper, and more plausible to prey on people in more and more different ways? So yes, we can already prey on people. I know we can do that. But in other words, are these technologies useful for even more efficient preying? Because at that point, then we do have a question that is where privacy becomes consumer protection.
I'm just curious, can someone ground this for us, just like how much does a list of people with, like how much does one of these data sets cost? Does someone know? Asking for a friend.
So just as a point of information, data sets that contain like credit card numbers and this like often go for like, $5 to $20 per entry or something like that.
Those are clearly legal though, right?
Yes.
How about legal things?
Oh, I don't know.
It's cheap. Like less than, maybe $10.
Per
I don't know.
like data point or what?
Someone who has access to a computer, like please fact check us, Google this. But yeah, it's like really, really cheap.
But the question is, will we get surveillance capitalism on steroids?
Right, so
that's the question.
Yeah, I think your question then is basically, I think the question you're asking is like, are there ways for generative models to extract more information, more personal information from people than is currently getting shared on social media? And like, frankly, my answer to that would be social media is very good at extracting personal information from people. So you probably don't have to juice it up that much, but sure, you could like post things on social media that would get engagement from people in a way that like you then don't have to have humans doing it. Like you could.
So here I'm going to make here I'm going to push back slightly. In the world of social media, it's the dirty little secret is that the companies promise that their predictive algorithms are quite efficient, and they sell that to advertisers when in fact they're not that efficient, and they're not that good, and they're really bilking their advertisers a lot, right? So what I'm asking is, suppose that we could harness these technologies to basically make good on the promises that are currently being made by the social media companies. So we could really have some really good surveillance capitalism that could really target vulnerable populations and then subject them to all sorts of offers which would basically expropriate from them and oppress them. My question is this technology, can we use this technology for that purpose?
I guess I'll say that, like, I guess let's start with the basics. Like, first of all, do we consider, say, targeted advertising itself a privacy violation? I see you like shaking your head. But like, I guess you're saying that I'll make the same argument or same comparison I made before, which is if you crank that up to 100, does it become a privacy violation now?
It has to do with vulnerability. It has to do with the vulnerability of the target. So in other words, I like Dr. Pepper. So somebody says, "You like Dr. Pepper? Fine. Here's some Dr. Pepper." You know, you might think it's creepy or spooky, but it's not a serious problem. The real serious problem is you find, you know, some 75-year-old person and you sell them a financial product they can't understand, and it basically bleeds them dry. That's what we're worried about.
Can I jump in?
Yeah, sure.
So it kind of sounds like we're talking about like traditional ML or deep learning, like recommendation algorithms, just like, you know, filtering, collaborative filtering, versus like generative AI. So another thing I want to call attention to is generative AI has lots of different mediums. So you could do text, you could do audio, you could do images. Something that we haven't really considered is how easy it is to reproduce people's voices, given very little amount of speech that they have. So one great way to spoof people is to pretend to be someone that they know. And to pretend to be someone that they know with that person's voice. So we can get a little more like imaginative, if you will, about how we violate people's privacy.
So what you're telling me is the problem with these people here is they're not devious enough. And you are.
No. I know these people on this panel personally, and they are devious enough.
I just want to like mention, since it was brought up before, like the deep fakes and copying voices. I'm not. Maybe this. I think that's bad, but I'm not sure if I consider that a privacy violation. I just think it's something else bad, which, you know, a consent violation of usage of something. But again, I'm not sure if I would fit into privacy personally.
Yeah, I guess the reason I've been quiet is because I very much like attacks, but I don't see this as a privacy attack either. I see this as just like a standard security attack. Like exploiting vulnerable people is bad. Like don't exploit vulnerable people, but I don't think it's a privacy violation to exploit them.
Is that legal advice?
Yes.
But I mean, at the same time, I think that this does expose the fact that like there's, you know, there are white hat hackers who are working on these models, but there probably should be more, right? Like we should be figuring out what the bounds are, what the kind of capabilities. Like, yeah, I think you could be very creative, and maybe I don't want to list a bunch of things. We could talk after the mics are off about like different things that you could do with these models to try and elicit that. But yeah, I mean, it has to be, yeah. Anyway.
I just want to make a quick clip. If we can copy 10 Nicholas Carlinis, please do that. I think it would be really big boon for the research community.
I mean, if you want like bad things that you can do, I mean, you know, like let's just. We can go to like, you know, sending spear phishing and these kinds of things, and like, you know, automating all the kinds of abuse that currently requires people. But again, like not privacy. Maybe we can go to the question.
But I just want to explain what's going on here. The conversation we're having here has to do with the question of why we care about privacy. In other words, if you think that what the harm of privacy is the mere fact of breach of trust, of disclosure or use in a right, then yeah, maybe not. But if you think that the harm of privacy is the creation of vulnerability, that is the added additional bad thing that happens, that privacy opens the door to, then you can see now the connection between what we call privacy violations in the narrow sense you're talking about and the broader sense of exploitation. That's how they're related.
Yeah, I had a question. So one of the places where I think the new generative AI models tend to differ from traditional machine learning models is the fact that we have a giant pre-trained model, right? And so one thought that I have is, or one question I have for you is, do you think it's better to partition off the model and only allow access to it via a service, sort of like Miles was talking about in his presentation earlier, where you could potentially defend against privacy attacks that you don't anticipate? Or is it better to have a public model like Meta has done, where many people can analyze it and identify the potential risks?
I want public models. I feel like trying to hold things secret because you're worried about what might happen only delays the problems you're going to run into eventually. And it's much better to just release the thing. If you're going to either don't release it, and then you're safe, or if you're going to release it, just actually release it, and then let people actually do the security analysis of it in order to see what the worst case looks like. Trying to hold things behind an API and saying that, well, when we do this, like, we're suddenly going to make things private, we're going to stop things halfway through, is not going to work against the motivated adversaries, and I'd like to be able to see the security analysis of the things the real way through. But maybe the OpenAI person feels differently.
I mean, how much time do we have? My colleagues and I have published a bunch of stuff on pros and cons of kind of, different release strategies. I think it's a complex issue. I do worry a lot about the implications of having sort of big jumps in capabilities. Like, I think we're still scratching the surface of GPT-4, so it does make me nervous when people are like, just release it. Particularly when there's still this Cambrian explosion going on of pairing models up with tools, and I think it's really hard to say what the implications of that will be. But I also understand that there's benefits in terms of open research and speeding up defenses. So I think it's complicated.
I'll say that it seems like many of the style of attacks we come across seem to be apparent at many different levels. For example, a classic thing in image classification is adversarial examples, which a lot of people know, and these are like kind of a toy problem. Nobody really cares. It's not a real threat. Okay, so we tried our best as a community to solve them. Didn't really solve it. Okay, no worries. Who cares? But then recently there was a talk that Zico Coulter gave yesterday, where it seems like maybe you can do the same style of attacks, like using similar principles against some of these large language models to bypass security filters. And seems like the stakes have raised a little bit, and we see the same issue again. Maybe you can see where this might go in the future, where we go up, the stakes raise again and again. So this is basically echoing Nicholas's point, where it's helpful if we can find these things on the simplest possible model, where we can either foresee future issues or solve these future issues as open as possible. Because I think, at least right now, we're not at the very, very high stakes level that we might be 10, 20 years from now. Who knows?
Although again, so first the invitation, the Privacy Law Scholars Conference happens every June, and I welcome you all to submit things. The call for papers is January. The next conference happens to be at my home in Georgetown Law, and these conversations are very much the conversations we've been having for a decade. So here's the thought experiment question, which is, the one thing none of you have said is context, and so Helen Nissenbaum is associated with saying, like, privacy means lots of little things depending on the social context. I worry a little bit about the kind of majoritarian viewpoint that's been on the panel so far. Like, social security numbers, that's, privacy, but, and often to an individual privacy, something like deeply personal to them. So the thought experiment is, can you work this problem from the other side? Could you train generative AI, large language model, that would never, ever, ever say anything about individual people whatsoever? So it wouldn't imitate the style of William Shakespeare, wouldn't be right. And so in a kind of differential privacy sort of move, you'd be very confident that certain types of privacy harms, ironically, probably not all of them, but certain types of privacy harms would not be achievable. Does that feel tractable to the computer scientist? Like, I know there's some like very difficult entity recognition, maybe that's the wrong phrase to know who the people are and who the people aren't. Maybe some grad student in the room can pursue this, or does this just seem like flight of fancy thought experiment that would never work?
I actually have a response, but
Yeah. Sure. Yeah, if you have a response, please go.
So I have like an NLP background, and there's this thing that people are now getting into called theory of mind, and that is like one thing that I personally want to kind of work on when you're like reasoning about, oh, I want to think about privacy. One thing you could do is use theory of mind. So it's basically you're trying to keep state of what is happening, what is the secret, is it okay if I share it with this person or not? And there are methods right now that do decoding based on theory of mind. It's very new. I think there was a theory of mind workshop yesterday here.
So I feel like theory of mind is the best thing you can get with NLP if you want to work on this.
I'm at a higher level. I will never say anything about any people ever.
Well, I feel like again that falls under theory of mind because you have to like figure out who's the person.
Okay.
And like, because, yeah, so it's that kind of figuring out and the reasoning, and I feel like that starts with theory of mind, but you're way far from that. Like, you don't have benchmarks, you don't have data sets. So this is like one of the things that I'm really interested in, so that's what I wanted to, but yeah.
This is also some people use the word alignment for this. This is another thing that you can try to align a model to do.
Well, I guess I'll start by going back to the answer to the previous question. I come from Los Alamos, where the concept of taking a technology and sort of putting it in public space and letting it work itself out. Let's just say it's starting to feel a little bit poignant as we experts in ML at Los Alamos are really getting into these details. My question is more of a thought experiment that's pretty simple. So we have fictional examples, say Sherlock Holmes, who are brilliant, can look in at a situation and from small details that might not be totally obvious to anyone else, infer really personal and intrusive details about somebody's life. So my question is, from a philosophical, but mostly from a legal standpoint, what's the difference between having a handful of brilliant and specific and relatively expensive people like Sherlock Holmes walking around and having some ubiquitous high-volume tool that can make that kind of insight and scale?
I would argue this is mostly a legal question, not a technical question, because, I mean, we already see this, right? Like, there's a difference between, I'm going to sort of say something about the law that, a little bit, but I'm sure the lawyers are going to correct me on what I'm wrong about, but there's a difference between if I'm standing on the street and looking in someone's window because it's open, versus the case of, like, I am standing far away with my, like, magnifying, like, telescope looking through someone's window, right? Like, they may seem to be the same, but the law treats them very differently. Technically, they are the same thing. I am sort of using optics to, like, in one case, the lens in my eye, in the other case, a lens I have manufactured with glass to look through a window. They mean very different things. Like, in some sense, I don't think technically it's very hard to draw a distinction here. I think this is mostly a legal question.
The difference has to do with power relations. So Sherlock Holmes is an agent of the state. Well, he's a private detective, but he's working with Scotland Yard. And if Sherlock Holmes were to take his inferences and use them to blackmail people, or use them for all sorts of things, then in fact he would be committing a crime or a civil violation. So the real question is how power is being used. Another question is there's only one Sherlock Holmes, and he's a fictional character. It's not actually even clear that in fact there was ever such a person who could do these things. But let's assume there was such a person. Then it would be very interesting. The question is, what controls would be placed upon his abilities? Because in fact, he would have power. He would have concentrated power. You're at Los Alamos, so you understand what concentrated power is all about. In the law, we're very worried about concentrations of extreme power because we're worried that people who are unchecked with extreme power will use them in all sorts of bad ways. And that's why a lot of what privacy law is about the accountability for power. That is to say, it's the association of different kinds of checks on people because of the fear that they will take concentrated power and use them in bad ways. So Sherlock Holmes, you see, is an interesting example because if you had a group of Sherlock Holmeses, I think there would be enormous push politically to basically control their movements and their behaviors and how they did things. For example, we might say they can only work for the state and they can only work under certain conditions. And that if they violated their abilities, for example, by leaking things to the Russians, we would go after them, you see?
Can you talk about the example?
So I could refine that slightly, because I think in this context it's appropriate. We do have large teams of Sherlock Holmeses running around. In fact, the descendants of the Pinkerton detectives, they attack unions not really under the employment of the state, simply under the employment of corporations, by collecting intrusive information and doing exactly the kinds of things that we're describing that these large language models might make easier.
Yes, but you're assuming that that's legal, what they're doing now. It's not necessarily legal. And in fact, the problem is they're often not called to account for things they do that are not legal. That's centrally what the question of privacy is about. When people talk about privacy as being about power, this is what they mean. The use of knowledge in such a way as to take inappropriate advantage of others and to treat them unjustly, that's a lot of what privacy is about.
Oh, I was just gonna ask if you could talk about like tracking on cars. Or like San Diego, I live in San Diego, and we're now fighting quite a bit about a new, license plate reader surveillance system that's going into all the streetlights again after we had them take out the first ones. So clearly some of these things are treated, I mean, I don't know, is the city of San Diego just like operating illegally? Like, yeah. I'm not a lawyer. So
well, is the state doing this or is private parties doing it?
It's the city of San Diego.
Right, so it's the state doing it.
Yeah.
And so then the question, so it might be in violation. Unfortunately, it probably isn't in violation of the Fourth Amendment because the Fourth Amendment has been watered down so much. But yes, the question would then be whether or not there is some restriction on the government's ability to collect information, what its justifications would be. We do have a constitutional provision that is designed to prevent the state from abusing its ability to collect information and using it against its citizens. It's called the Fourth Amendment. Unfortunately, our Supreme Court has over several decades so watered down this provision that in fact states can do all sorts of bad things they shouldn't be able to do.
Since you opened the door for that.
Not language models, can we?
I do.
Yeah, we're not doing large language models anymore. We're doing state abuse of power.
Yeah.
Yeah, I just want to throw out there that like, I don't know if like meeting the law is like way too low of a bar. Right? Like when I teach my students, I encourage them to do the thing that I think is morally, what they think is morally right, which I think is kind of an entirely separate question, especially around privacy, than what is legal.
I think what's interesting about this for like making a product as well is like what's legal is a very low bar, and user perceptions of privacy matter also. And so that sometimes feels like a harder standard to meet. Shall we move on to the next question?
Thank you very much for the panel and the presentation. I just have an issue with privacy in AI because I feel that it's a problem for rich people, rich companies. Let me explain. We had the same issue with the web, privacy in the web. The solution was GDPR. What happened with GDPR? The big companies benefited from it, not the open source project, not the startups. Meta, Google, they are the ones that push this kind of regulation because they have the tool and the competencies and skills to implement them. We are seeing the same now with the AI Act in Europe. Who pushes this kind of law? Again, the large corporations, and who inspire open source projects. So I'm really afraid that these questions and all these discussions about privacy in AI will again only benefit large corporations. What do you feel about this?
I think privacy is for everyone. But yeah, I mean, certainly different people have different priorities.
I mean, I don't know, folks might have other thoughts about the corporations question. The concern I have actually is that you can sort of pay for privacy, right? Like if I want to have email without Google reading, I mean, not literally reading, but having access to, making predictions based on all of my emails, then I'm setting up my own server. I'm like getting all of this stuff running, and that costs me a lot of money, right? Like it literally costs me money, maybe also technical expertise to be able to do that. So, I mean, I'm sure there are also questions directed at kind of larger corporations benefiting more from regulation than smaller corporations. Like, yes, I think that's also a problem, but also on an individual level, I think you see the same thing where privacy is something only the rich can buy.
But earlier we had talked about differential privacy, tools to implement privacy in machine learning, and this is expensive. And again, who can afford to implement this complex system to ensure privacy? It will again benefit these companies and organizations. So my issue here is that we know how to improve the privacy of AI, but we know it's expensive.
Yeah, I think, I mean, it's a trade-off, right? Like you need also software engineers to make any sort of software, which is also expensive. I mean, it's a new expertise, that's for sure, but hopefully we'll do the cost-benefit trade-off about like how much it's valuable to our society to impose these sort of restrictions, and over time, hopefully, we'll have more people trained in the relevant things to match these and developing more expertise. So it's not like there's no easy solution. Yes, it will cost something, but hopefully we can converge to an equilibrium which is good for society overall.
Can I jump in and add a bit?
Oh yeah, I mean, actually, yeah, why don't, yeah, there's not just, there's two open people here, and one of them is a European open person, so he wins.
Sorry, I have to strongly disagree. The idea that GDPR and the AI Act are being pushed by large corporations is entirely the opposite.
Yesterday we had an open letter from GitHub, from Hugging Face, and all the smart companies that were saying exactly that this will benefit large corporations.
It doesn't. They're fighting it, they're getting all the fines and everything. Under some point, under some circumstances, it can look like they benefit, but this is GDPR benefits. Didn't take the argument. This direction, did you? Very pro GDPR. Very pro GDPR. It's good for citizens. It's good for. I've used it personally. I think it benefits citizens. It benefits everyone. The AI Act is entirely different. I think it's going to be a disaster, but I don't think it's being pushed by large corporations, and it's not going to benefit them. Yeah.
I'm going to stop this one here and move on to the next question. So we have 2 more and 5 minutes. So if you don't mind, we'll finish that one offline. No worries. Thank you for your input.
I have a question for Professor Balkin. You said AI companies will soon make the free speech argument, but their arguments might not be as strong as social media companies' arguments in the context of content moderation. Is that because AI-generated outputs are not always representing the company's standpoint? And if that is the case, AI alignment efforts like suppressing unwanted outputs probably make it stronger for AI companies to have a better First Amendment argument?
Let me see. I just want to make sure I got the question right. Is that the way in which AI companies are fine-tuning their models makes them more vulnerable, makes them less likely to be able to make use of the editorial argument than social media companies which are engaged in content moderation?
They can use more the editorial.
Yeah, I mean, that's what the immediate analogy that companies will probably try is to argue that when they fine-tune their models to prevent replies from engaging in hate speech and various other kinds of things, that what they're doing is they're engaged in editorial function. And the analogy is to newspapers, editing newspapers. And that it's no different than what social media companies do when they edit or demote content produced by end users. Nobody doubts that the social media company basically is hosting the speech of people and it's editing that speech. So then the question is, does that mean that the AI company is conceding that it basically is the host of the speech of the AI? All right, that is, in other words, that's what the question is. And that will put them in a different litigation posture than if they say, hey, it's just a product we created, other people give it prompts, the prompts come back, there's nothing, you see, it's not our speech, it's just you see what I mean? And so that's what the puzzle is. The puzzle is whether or not the editorial argument works as well in the context of AI companies fine-tuning as the social media companies' argument does in the context of content moderation. I can argue it both ways. I just think it's not as obvious an argument. And in fact, there are many people who think that the social media companies' argument is not, what they do is not editorial. It shouldn't even get put in the same category as what newspapers do when they edit something which is the work of a newspaper.
But even AI companies are currently doing like this. Those alignment things are more is closer to like newspapers' editorial functions compared to.
Yes, but now notice that the argument would then follow from the argument, if we accepted the editorial function argument, that an AI company would have the right not to fine-tune. That is to say, if an AI company said, we have decided that we are perfectly happy with the AI spitting out all sorts of harmful information, hate speech, all sorts of things, and we have a First Amendment right not to tune the model. And if you try to regulate us for not fine-tuning the model, we will use the Constitution to prevent you. That's the flip side of the consequence of the editorial argument.
Let's move on to the last question.
Thanks very much. Stephen Harris from Illuminate. I am originally from Australia, but now I spend my time thinking a lot about EU law. So my question is focused from the perspective of EU law, which I appreciate takes most, if not all, of the panel away from your comfort zone. But I just wanted to point out that data protection, whilst obviously having a great deal of overlap with privacy, is actually in EU law considered a separate or distinct right, according to many scholars. And under the GDPR, a lot of targeted advertising, or at least the manners in which cookies are currently used to profile users, is considered unlawful. It might be that these things can be done lawfully under the GDPR, but as it currently stands, the IAB's transparency and consent framework falls far short of the GDPR. This is not my opinion, this is legal opinion, like legal decisions that have been made by courts and data protection authorities. So my question, returning back to the point that I think Professor Balkin was alluding to, is when you take these profiling technologies that feed people the ads and the content that the technology thinks they want to see, and you layer on top of that generative AI, large language models, what happens when the model not only predicts the most likely token to be the next token, but also is predicting what it thinks the person wants to hear. So i.e., if I go into Google and search something right now, as we all know, I'll get a different set of results to any one of the members of the panel, because we all have different profiles, and Google's going to, the search will read me differently, as it were, as a searcher. So what happens when the search query in a large language model, from a large language model, is returning a different answer depending on who's asking the question? Do we see this as a privacy violation in the same way that targeted advertising presently is in Europe?
So you're kind of asking if model personalization is a privacy violation stated.
Thank you. Yes, perfect.
Does anyone have any opinions on this?
It's not obvious to me how my large language models make this any different than any other setting. I don't see a way in which the fact that this is a large language model makes it any different than if it was anything else personalizing in the same way.
I think potentially the harms are worse because it's interactive and that personalization can make it worse. But as far as like a privacy violation goes, I'm also like, I think that would be similar.
Yeah, I mean, I would just add that, yeah, just to plus one that, like, hyper-personalization, not just of targeting of ads, but actually the content of ads could be definitely, supercharged with generative AI, but I'm not sure it changes the privacy question.
I'll kind of agree that, yes, as long as it's only shown to you, the personalization, then yeah, I don't think it's a privacy violation. If it's shown that, like, okay, here are Gautam Kamath search results for everyone, and then maybe it reveals something, or similarly personalized model, then yeah, that would of course be a problem.
But of course, again, if you were to see my search results, if it was still personalized for me and I would share them, you would have the same problem. It just might be worse in some sense.
But the point I'm trying to make is that the underlying personalization is already itself it's a GDPR violation.
Yeah, that may be the case, but I don't see how the language model changes. Like, the argument is the same. If it was true there, then it's true with the language model. If it's not true there, it's not true with the language model. I think it might be made worse a little bit or a lot, but I don't think it's fundamentally a different object.
Right.
I think the question of like whether or not generative AI changes the privacy landscape is a great place to end. our day today. Thank you all for coming out, and thank you to the speakers for staying on time, wow, and for your provocative thoughts. Thank you also to all of the organizers in their little hats. You can find us later if you have any questions or thoughts or feedback. And then if you spoke today, if you don't mind staying here, hanging back for a little bit, that would be fantastic. Do we have anything else to close with?
Thanks to the organizers.
So special shout out to Ludwig who recorded and live streamed. So if you missed something, you can go back and watch. Also special shout out to James who live blogged the entire thing. So if you prefer reading a transcript, you can do that as well. If you want to share this with your friends, that would be great. If this opens new questions for you, please let us know. You can email us. I think we've spread our website everywhere on the internet, so hopefully you'll be able to find us. Any other thoughts?
Do you guys have a mailing list or something you want
We
to?
do have a mailing list. We have a listserv that you're welcome to join. No one has posted anything yet except for me, so you're welcome to post on it. And we also have an organizer's email, so you can also reach us there. These are both accessible on the website. Cool. Nice to see so many of you, and thanks for sticking around until the last day of ICML.